Every time an app predicts customer behavior, a company studies sales trends, a bank detects unusual transactions, or a business decides what to do next using data, data science is working behind the scenes. And one of the easiest and most powerful ways to start learning data science is with Python. Hey everyone, welcome to this Applied Data Science with Python course by Simplilearn. In this course, we will start by understanding how Python is used in data science and why it has become one of the most popular languages for data analysis, visualization, and machine learning. You'll be learning how to work with important Python libraries like NumPy, Pandas, Matplotlib, Seaborn, scikit-learn, which are widely used by data professionals. We'll then move into handling real-world data, where you'll understand how to create arrays, work with data frame, clean data, analyze pattern, manage missing values, and prepare data for better insights. After that, we will explore data visualization, where you will learn how to turn raw numbers into clear charts and graphs that make data easier to understand. We'll also cover important foundations like statistics, linear algebra, categorical data handling, and basic machine learning concepts, so you can understand how data is used to make predictions and support business decisions. And by the end of this course, you will have a strong practical understanding of how Python is used in applied data science, from data handling and analysis to visualization and machine learning basics. So without any further ado, let's get started. Also, if you're ready to take your skills in Python and data science to the next level, check out this Simplilearn's Data Science with Python course. Now, this course is perfect for anyone who wants to master Python programming for data analysis, visualization, and machine learning. You'll be learning how to work with key Python libraries like NumPy, Pandas, Matplotlib for data wrangling and analysis. You'll dive deep into data visualization, feature engineering, and statistical models that are so important in the world of data science. Plus, you'll be getting hand-on experience through real-world projects like sales analysis, marketing campaign analysis, and many more. And upon completing the course, you will be earning a course completion certificate from Simplilearn, which can boost your career and showcase your new skills to the employers. Check out the description below for the link and start your data science journey today with Simplilearn. Before we get started, here's a quick beginner-friendly quiz for you. Which Python library is mainly used for data manipulation and working with data frames? Your options are Matplotlib, Pandas, Seaborn, or scikit-learn. Let me know your answers in the comment section below.
Introduction to data science. How many of you have heard the term data science, and what do you think data science is? This particular lesson, you'll be able to explain the basics of data science and its applications to derive meaningful insights, as responded by Varuni and Sakti Pandian. List the steps of data science process to solve problems systematically, and explore the Python packages for data science to efficiently perform data analysis, data manipulation, and data visualization. Also, you'll be able to describe the types of plots available for visualization to communicate data insights and trends effectively. Let's get into the introduction. What is a data science? You need to understand now. Data science is a multidisciplinary field that uses scientific methods, processes, algorithms, and systems to derive meaningful insights from structured and unstructured data. Right? So you need to understand what is a structured data and unstructured data. Structured data, you can see, as I found, many participants has gone through the SQL course. What are the data stored into the SQL tables in the form of rows and columns, right? Very good, very good. What are the data stored into the database tables in the form rows and columns? Like it may be a employee details, it may be a e-commerce order details, it may be a bank records, student details, right? Which contains column names, like for if it comes to bank records, name, account number, balance, address, email ID, mobile number as a column names, and all the records you'll be having, right? Which is called as a structured data, right? What is the unstructured data? Unstructured data, which doesn't have any particular structure. The data is in the form of a text, images, videos, or emails, which usually don't fit neatly into the tables. Like you can take the example of social media posts, which would be Insta comments, tweets, images, videos being shared on the social media. These all are called as unstructured data. Using a search engine or making a purchase on Amazon provides valuable data to data science driven software systems operating in the background. Data on interactions with online platforms is gathered to understand user preferences and suggest search results or items to buy. When you make a purchase, for example, if you are trying to buy a laptop, immediately you would be getting some kind of suggestions, right? What kind of suggestions? People who has bought the laptop also bought a wireless mouse, the earpods, and backpack, bag, and so on. How you get these references? Earlier, people who has purchased the laptop might have purchased those products, and it is analyzing the product you're purchasing and relating the same product buyers data and finally suggesting you some results. That's how the data on interactions with online platforms is gathered. So by this, what you came to know? Structured is organized, easy to search, and stored in database. Whereas unstructured data is free-form, scattered, and harder to analyze, but contains valuable information. Here you can see, I was telling you, data science is a combination of methods, scientific methods, process, algorithms, and systems, right? To derive meaningful insights, there is a raw data. From the raw data, I want to bring out, for example, I would like to give you an example related to purchases on e-commerce. Due to some sale happening on the e-commerce website, millions of people are purchasing the products. Soon after the sale completed, I'll have good amount of data in hand, and I want to analyze the purchase trends, like how many users has purchased mobiles. Okay, I'll get some amount of data, right? And over the data, I would like to perform further analysis. Age group analysis. What is the age group of people purchased different mobiles? And you might be getting the people with age group of 20 to 25 might have purchased some XYZ brand, and people from 26 to 30 might have purchased some XYZ brand, ABC brand, and so on. So that's how you keep on working on the data. Let's say there is an e-commerce application. When you take an e-commerce application, you'll have a structured data, right? Like order ID, product name, price, delivery date. And structured data helps to track purchases and inventory. Whereas unstructured data, under unstructured data, you'll have customer reviews, product images, social media mentions, chat support interactions. These all comes under unstructured data. And unstructured data will have reviews and comments, which helps analyze customer sentiment and improve products. And you can see when you're trying to make a purchase on an e-commerce website, you look at the reviews. Out of those reviews, you find the rating also. For X product, 2000 reviews has been given. And you'll see the rating like 4.4. That is the rating, overall rating for the product by those many customers. And you keep reading the comments and make a decision whether to buy or not. Right? In banking also, fraud detection will happen. Banking and fraud detection related. What kind of? You'll have transaction history, which is in the form of structured data, like account number, amount, location, and time. When it comes to unstructured data, customer emails, phone calls, and social media complaints. Structured data is used for tracking the balances and transactions, whereas unstructured data, like customer complaints about fraud on social media, helps detect suspicious activity and improve security. Right? So let's take it forward. I was talking about data science emerges from the combination of subject expertise and scientific methodologies and technology. Here you can see domain expertise and scientific methods. You have a large amount of data in hand, and with the help of mathematical and statistical models, you'll model the data, then perform some kind of analysis. After performing some kind of mathematical modeling over the data, we perform the analysis, then apply some scientific tools and methods, and use programming languages, data processing tools with the help of operating system, the predefined library support, and get into the data science and find the insights of the data. Right? By this, data science is a combination of subject expertise, scientific methodologies, and technology. With all the combination, we are able to achieve the data science. You can see an application of data science in healthcare, where wearable devices use data science to analyze data from their biometric sensors. What is happening? You have a wearable device. The data from the wearable device, for example, every day you are going for a workout and burning some X calories out of your workout. And you're also performing some 10,000 to 12,000 steps every day. Whatever the data is collected on the wearable device is transferred. Biometric data transfer is happening through the IoT gateway, Internet of Things gateway. As wearable device is a IoT device, it is controlled by internet. So the data which is available on the wearable device is transferred through the IoT gateway. If you are using iWatch gateway will be used, and data is transferred to the servers, and iWatch related the enterprise infrastructure will be there, where all the required data is being collected from millions of users, The collected data, over the collected data, they perform the data analytics. Like, let's say for a week and for a month, you'll get a dashboard on the engagement window. When you open the application, you'll get the dashboard with a lot of clear visuals, workout related visuals, calorie burnage visuals, your number of footsteps, all the details you'll be getting, right? By this, what you came to know, the wearable device, through the biometric data transfer, the data is being transferred to the IoT gateway, and through the IoT gateway, again, the data is getting transferred to the servers of the enterprise infrastructure, from where your data is pulled and performed data analytics. Here, all users' data is getting stored, from which only your data is being pulled and perform some kind of analytics, and performed analytical insights are being displayed onto the engagement dashboard in the form of visuals. And when you open the application related to the wearable device on your smartphone, you'll be able to see all these visuals, and you'll be keeping informed about the last 1 week workout details and everything. So that's how the wearable device will work, where you get all the information on the dashboard. Hey folks, are you following? Is the pace comfortable? I would like to know at this stage. What are the recent searches has been done? Most of the hits has been done. Those are kept as a reference, and it started referring to those suggestions, due to which your search becomes very fast and real-time analytics is made possible by modern and advanced infrastructure tools and technologies. With the help of the data science being used in the search engines, you are able to perform the search with the help of suggestions, right? And applications of data science under finance. Finance is talking about, this is a very good example which will make you clearly understand everything. Let's say using data science, a loan manager can easily access and sift through a application's financial details. As a user, I am applying for a loan, and you have a loan application portal. What loan application portal is asking you? It will ask you some details like your name, your salary, to which bank it is getting credited, right? Also, whether you are residing in a rented house or own house, marital status, recent salary hike, company name, many details it asks. PAN details. After taking all the details, it will transfer the entire collected data onto the servers. Okay, it will transfer entire data collected on the portal to the servers. You have an enterprise infrastructure here, which performs the data analytics over your data and transfers the data to the engagement dashboard. And engagement dashboard will generate your credit history, credit report, approved amount, and the risk. All the details, the rate of interest, the amount you are eligible, your CIBIL score, all these details will be displayed to you on the dashboard. And also, you'll keep informed whether you're eligible for the loan or not eligible. That is how the online loan application process is happening. Earlier, taking loan was a very tedious process. You need to call the bank executive. He used to collect the pay slips, lot of other documents, and move to the bank, process your application. There was a lot of waiting period. but all these are leveraged here. Yes or no? That is the beauty behind the data science. Next, data science process. What is the process involved in the data science? Data science involves the problem definition. What actually you want to do is a problem definition. Later, over which data? You need to collect the data. After collecting the data, see, without data, you can do nothing. So what kind of problem statement you are looking for and on which data? Okay, after collecting the data may have a lot of missing values. Missing values like might be phone number missing, might be age of the employee missing, somewhere salary is also missing, right? So data cleaning and exploration should happen to handle the missing values. Then feature engineering should happen. What feature you're targeting? Model building and training. Then model evaluation, model deployment. These are the different steps involved in data science process. Here, let's look into the every detailed step clearly. Problem definition. Clearly define the goal or question to be addressed through data analysis, forming the foundation for the subsequent steps. That's what I was telling you, right? What problem you want to address is all about problem definition. Data collection. Gather relevant datasets or information sources necessary to address the defined problem. So you need to have data in hand. So collecting the data so that what are the problem you are trying to address, the relevant data you need to collect and keep it handy so that you can perform various other steps are required for performing the data science. The next step is all about data cleaning and exploration. What does data cleaning and exploration will do? It will pre-process the data by handling the missing values, outliers, and other inconsistencies. What does this outlier mean? Just now I told you what is a missing value, right? Can anybody tell what is an outlier? Outlier is a very simple word. For example, if you take a class of students, most of the people who take exam might be scoring marks between, say if it is out of 100 marks, and there are 60 people, most of the people might be scoring around 70 to 90, right? And you can see few people scoring 5 marks, 10 marks, right? While performing analysis, you don't consider these marks because we consider them as outliers. Which is completely moving from the actual data. Outlier is a data point which is moving completely from the actual data. And when you consider these outliers, your analysis may go wrong. Your predictions may go wrong. So to avoid that, to improve the accuracy, you will ignore the outliers. Right? Hope you're getting. Fine. Next, feature engineering. Feature engineering is all about create or transform new features to enhance datasets information and improve model performance. If you want to perform analytics over the data, sometimes you may need new features. So for creating new features over the existing data and adding it to the dataset, we go for feature engineering. As you need large amounts of data to perform analytics, and some kind of feature generation should happen. So you'll get to know more detail while discussing the feature engineering topic. And model building and training. Develop a predictive or descriptive model using machine learning algorithms and train it on a prepared dataset. We need to train the model on the dataset. So develop a predictive or descriptive model using machine learning algorithms and train it on the prepared dataset. So we train the model most of the time. We train 70 to 80% with and test with the 20 to 30% of the data. So the ratio goes that way. Then model evaluation and deployment. We evaluate, optimize, and fine-tune the model for peak performance, then deploy it into a production environment for real use. So evaluation, optimization, and fine-tuning of the model will happen. And I say interpreter, right? Interpreter means, for example, you take any other language. I am taking some 5 lines of code. I'm taking 5 lines of code, and here I have error at line number 2. And also I have error at line number 4. If it is a Java or C# code, C++ code also. If I give this code, let's say this is a test.java. Test.java. When I give it to the compiler, it will compile all the code on one go and give you the list of errors. Right? List of errors saying that there is an error at line number 2 and there is an error at line number 4. When you consider the same code to be a Python code, same code to be a Python code, and let's say it is a test.py. When I give this code to an interpreter, it interprets line by line. When there is an error at line number 2, it stops compiling it, interpreting at line number 2, and it gives you an error. Unless and until you correct this error, it will not take you to the next line. Okay, let's say I have corrected this error and again submitted to the interpreter. It interprets all the 3 lines, and at the 4th line, it has found the error, and it again prompts you the error. When you correct this error, it will take you the next lines. So line by line interpretation will happen in Python, whereas in Java, the compilation will happen. The entire code will be compiled on one go. And Python is a high-level language. How I can say it's a high-level language? Whatever the instructions you write is closely resembling the English language. Hence, I say it is a high-level language that supports object-oriented programming. You might be aware of object-oriented programming, like the object-oriented programming principles, abstraction, encapsulation, inheritance, polymorphism, right? So Python is supporting all the object-oriented programming principles. Hence, we say it is a object-oriented programming. Ease of use and simple syntax. How you can say ease of use and simple syntax? This is very important. Let's go and open online GDB compiler. Right? If you want to print hello world using C language, you can see I'm selecting C language. So only to print hello world, we need to write these many lines of code. How much? 1, 2, 3, 4, 5, 6 lines of code. When you run, just a minute. When you run, you'll get hello world. Can you see? But when it comes to Java also, you can see 1, 2, 3, 4, 5, 6 lines of code. Again, I'm running, we get the hello world. This is related to Java. But the beauty of Python, you'll have only one line of code to print hello world. Just you run it, you get it. That is the beauty of Python. With one line of code, you are able to print hello world. When it comes to the other languages, it is taking more lines of code, right? Hence, I say it is simple syntax and ease of use, very handy to program. Earlier, most of the universities used to have C as a starting programming languages. But now, most of the universities has revised their syllabus and came up with Python as a first programming language. That is the beauty of Python. Scalability when compared to R. Python applications are more scalable. It can be given to large number of users for accessibility when compared to R. Hence, we prefer Python as a best suitable language for data science. Availability of wide variety of data science libraries and packages. We have different libraries like NumPy, Pandas, SciPy, Seaborn, Matplotlib, and many more, which supports data science related processes. Hence, I say Python is best suitable as it has wide range of libraries and packages. It is compatible with all major operating systems. Of course, Python, you can write Python code on Mac, you can write Python code on Linux, you can write Python code on Windows, many more. Creation of new data science libraries daily by a vast number of online user communities. There are coming up new libraries which supports Python, and using those libraries, you can perform data science. You also have a powerful data visualization libraries in Python. Hence, we recommend Python as a best suitable language for data science. Have you got the clarity here after this discussion? Participants, even Navin Raj. Navin Raj, I hope your doubt got clarified. Great, great. Next, it's right time for us to look into the packages for data science. NumPy. NumPy is a Python's library for data scientific computing that supports large multi-dimensional arrays and matrices and includes a comprehensive mathematical library. What is that NumPy is used for? Please try to understand. If required, document them. Very simple one-line thing. What is that? NumPy is used for, is a Python library used for scientific computing, and that supports large multi-dimensional arrays and matrices. I can tell you a simple thing. For example, you want to perform matrix multiplication. If you want to perform matrix multiplication, 2 by 2 matrix, through programming, it may take 20 lines of code in Java. If you want to perform 3 by 3 matrix multiplication, it may take 30 lines of code in Java. But when it comes to Python, it hardly takes 1 line of code with the help of NumPy. That is a beauty. So you need not write any hard coding for performing matrix multiplication. You use the required function and you'll get the desired result. That's it. That's the beauty of NumPy. Use NumPy to perform complex mathematical operations on large datasets such as linear algebra calculations, statistical analysis, and Fourier transformation. You can see here financial analysts use NumPy for quantitative analysis, such as calculating the mean and volatility of stocks to invest, to make investment related decisions. So that's how NumPy is useful, right? So what is NumPy? NumPy is a Python library for scientific computing and for working with large data sets. To create large multi-dimensional arrays, we go for and Pandas. Pandas is a library for efficient storage and manipulation of structured data such as time series and tables. Here, e-commerce applications use Pandas to analyze customer purchase history, to recommend products and a personalized shopping experience. Pandas contains a data frame which will help you in storing the data in the form of a structured format. Let's say there are, as I told you, right, recommendation of products. If you're trying to purchase a smartphone, immediately it will give you some suggestions, recommendations. People who bought a smartphone also bought the screen guard, a pouch, and earpods, many more, power bank. So it will analyze the data and it will analyze customer purchase history to recommend the products and personalize the shopping experience. Researchers use the Pandas to manage and analyze large datasets of health records to identify trends in the disease outbreaks. When it comes to the health related issues, for example, some X person might be suffering with a heart related disease. Researchers will use these reports and relate or perform some kind of analytics with some other thousands of records and will identify the trend and come out with the discussion. A person with the age range between 35 to 45, only 2% of the people are getting these kind of diseases. And there is a chance that 20% of the people will get at this age. So this kind of analysis can be performed over the data using Pandas. SciPy. SciPy stands for Scientific Python, is an open source library built on top of NumPy and is used for implementing scientific formulas, PV equal NRT and so on. It is tailored for scientific and engineering applications such as weather forecasting and drug discovery. So engineers use SciPy to solve complex mathematical problems in structural engineering such as stress and strain analysis in materials. Okay, so most of the time SciPy is used for structural engineering and weather forecasting, drug discovery, and so on. Stats models. Stats models in Python module that provides classes and functions for estimating many different statistical models and conducting statistical data exploration. Like we have a couple of examples here. Market researchers use stats models to perform regression analysis to understand how different factors such as advertising spend affect sales. Right? Advertising spend is affecting scales. It's like, say, there is a X product X, and I want to improve its sales. So to improve the product X sales, I want to invest some Y amount in the market for marketing and advertising the data. And I will analyze the trends before advertising and after advertising. When I perform modeling on the data and pull the data related to the sales before advertising and after advertising, yes, I'll be able to understand whether the advertising amount spent is affecting the sales or not. And also, product analyst will use stat models to evaluate the impact of public policies on social media and economic outcomes through statistical testing and analysis. Right? Scikit-learn. Scikit-learn is a widely used open source machine learning library for Python, known for its simplicity, ease of use, and versatility in handling various machine learning tasks. What could be the various machine learning tasks? You can see here. There are a few examples. It identifies objects in images for autonomous vehicle and facial recognition system. You can see autonomous vehicles, driverless cars. So driverless cars are using scikit-learn to identify the objects and accordingly make a autonomous movement in the vehicle. It is also helping to detect fraudulent transactions in banking and e-commerce platforms. Recently, I was trying to perform a transaction of a big amount on some platform. My transaction was denied and immediately I got a call from the bank. And it is a IVR call, interactive voice response call. It was asking the recent transaction has been happened on your card with the so-and-so date, so-and-so time on so-and-so platform. To confirm, say yes. And I said yes. Later, I was able to perform the transaction. And it is detecting the fraudulent transaction. See, it might be having my spending history. And none of the spending history is matched with the new transaction I'm making. That too, big amount. So immediately I got an alert from the bank. So internally, it is performing the scikit-learn to detect the fraudulent transactions in banking and e-commerce applications. It is also analyzing the customer reviews for sentimental classification in marketing and social media analysis. You can see for a product, you'll get a rating automatically, and you can click on the different tabs to understand the sentiment analysis, whether positive, negative, or neutral. If it is negative, what way they are not unhappy. If it is positive, what are the best things related to a product? And if it is neutral, obviously, we are not worried about the neutral comments, right? So scikit-learn will help us to analyze the customer reviews for sentiment classification in marketing and social media analysis. Matplotlib. Matplotlib library is a comprehensive tool for building static, animated, and interactive visualization. See, always remember, instead of displaying the data, raw data or a processed data, visuals speak much louder, right? When a cricketer is walking onto the ground, a lot of statistics gets displayed about his recent matches. What are the recent matches he has played? What is his performance? If he's a batsman, how many runs he has made in the recent matches? Every detail will be displayed on the screen. So, visuals are much louder than the actual process data. Hence, visualizing data is most important. Even a layman will be able to understand when he is presented with a visual. And Matplotlib is helping us to create such a static, animated, and interactive visuals, including the line plots, scatter plots, bar charts, histograms, pie charts, and many more. And Matplotlib is an open source library and can be used freely. And we discuss Matplotlib in detail in the upcoming. Seaborn. Seaborn is a data visualization library, but this is built on top of Matplotlib. The reason it provides a rich visuals compared to Matplotlib. It provides high-level interfaces for creating attractive and informative statistical graphics like histograms, box plots, violin plots, heat maps, and error bars. It also simplifies the process of creating aesthetically pleasing and informative plots, especially for statistical and categorical data. Fine. That's all about the C1. Fine. Next, Plotly. Plotly is a, again, Python library only for creating interactive publication quality graphs and visualizations. It is suitable for web-based applications. It enables Python users to create interactive and customizable visualizations for data analysis. So, what is that? Interactive and a customizable visualization. It is helping us to create. Meanwhile, various plot types, it supports various plot types such as line plots, scatter plots, and histograms, which enhance data exploration. So, types of plots with examples now. Types of plots. We call this as a line plot. A line plot displays the data points connected by straight lines. Can you see? These are the data points. Number 1 data point, 2, 3, and 4. 4 data points are connected. Right? Often used to visualize trends or relationship between two variables over time, or continuous or other continuous intervals. A line chart visualizes stock prices over time, tracking trends and marketing investment decisions based on historical data. You'll be able to access the PPT in your materials. If required, I'll share you, not a problem. From my side also, I'll share you. And it displays temperature variations throughout the year to analyze seasonal patterns and plan agricultural activities effectively. So line plot is will give you some clear understanding between the two variables and variable trends. Like for example, let's say a product X price in 2010 and a product, the same product price in 2020 and 2026. Year-wise price you want to map. Obviously, it will be a line chart, increasing trend, right? It will be like a line like this. Oh, sorry. It will be a line like this, straight line. It keeps on increasing. So as the year increases, price is increasing. That would be the trend you can understand. So relationship between the year and price. Next, marker plots. A marker plots display data points with markers. You can see marker. Circle as a marker here, right? Useful for scatter plots and visualizing individual data observations. Marker plot is used to display individual data points on map, such as marking specific locations for a survey. It is employed to plot stock prices over time with markers indicating specific events like buy or sell signals. So at this point, selling is happened. At this point, buying is happened. That way, it is going to indicate you the marker plots. Scatter plot. Scatter plot is all about the collection of data points plotted on two axes, both horizontal and vertical. You can see a lot of data points scattered here. What does this data point indicate? Here, see, here it is indicating the data point related to x-axis is somewhere +2, right? Close to 2. And here close to 4.5, right? 4.5. So 2, 4.5 would be the data point value. That way, x-axis and y-axis plotting will happen. The scatter plot analyzes relationship between two variables, like comparing height and weight in a population. And it helps us to visualize the data clusters, such as grouping students based on the exam scores. So most of the data points are here, right? If you can understand, most of the data points are residing here and also here, right? So that way we'll understand. When you collect, let's say there is an apartment with 500 flats. There is an apartment with 500 flats. In an apartment with 500 flats, we are collecting the income of every house. Income versus age. Income versus age. We capture. Income and age here, and you keep plotting the plot. Then you'll get to know what age of people are more with a particular income group. So that kind of analysis can be performed with the help of scatter plots. And the types of plots, area plots we have. Area plot represents data with shaded area, useful for showing cumulative proportions, cumulative totals or proportions over a time. And you can see here A, B, and C, right? An area plot visualizes cumulative data changes over time, such as tracking total sales, revenue over successive quarters. It illustrates the distribution of data categories, different categories, contributions to a whole, like displaying market share evolution. Right, that's all about area plot. We'll discuss area plot through an example as well, don't worry. And types of plots, bar plot. Bar plots are rectangular graphs that show identical vertical and horizontal data comparisons based on another axis. A bar plot compares sales of different products over a month. Sales of different products over a month. See, for example, I'm taking some 5-month data analysis. On month 1, products X got sold only 25 units. Later, close to 50 units. Later 50 above units. Later 75 units. Later, on 5th month, altogether 200 units got sold. So that way you can relate the bar plots. It also displays student grades in different subjects. Grid plots. Grid plot assists chart viewers in determining what value an unlabeled data point represents. Grid plots enable side-by-side comparison of multiple plots, enhancing visual analysis. So you can see it's almost similar to the line plot, but you have a grid in between, right? Can you see? A grid. They enhance presentation clarity by organizing complex information systematically. Likewise, histogram. Histogram visually displays the distribution of dataset by dividing value into bins and representing the frequency of each bin and bars. Here, bins we divide the data into multiple bins, multiple bars, nothing but, okay? So that we can categorize the data in a very clear way. Histograms visualize the distribution of numerical data like income levels or exam scores. They help make inferences about data characteristics and underlying patterns guiding decision-making processes. So you have different bins, and by this, what you came to know, your data is broken down into multiple pieces and grouping them as a bins so that further analysis over the data will become very easy for us. Pie chart. Pie charts are circular graphs in which data are plotted within the components or segments of the pie. See, data is plotted here. Pie plot shows the proportions of a whole like market shares or survey responses. Out of survey conducted here, few people, 30.7% of the people got registered for Ruby and 23.56 people, 26.3% people were registered on Java and so and so. They simplify complex data by representing it in an easily understandable format. And most importantly, examples of all these plots are provided in data visualization lesson, accompanied by detailed explanations and Python code. So need not worry if you have understood to whatever the extent you like feel comfortable, and the remaining part you will get more clarity while discussing the data visualization lesson. Fine. Yeah. Key takeaways. We have seen data science involves the analysis and interpretation of data to generate actionable insights. NumPy, and we call it as a numerical Python, is an open source library predominantly used when working with arrays. Seaborn is a data visualization library in Python that is built on top of Matplotlib. And Python is preferred programming language for data science projects across industries. Okay, hope we can proceed. Let's look into the introduction to NumPy. This particular lesson talks about fundamentals of NumPy, advantages of NumPy, NumPy installation and importing, and NumPy array object and creating NumPy arrays. What is NumPy? As I have been telling you, NumPy stands for Numerical Python. Is a free and open source library that is mostly used for mathematical operations in scientific and engineering applications. It is a Python library used for working with arrays. It consists of multi-dimensional array of objects, multi-dimensional like 2-dimensional, 3-dimensional arrays we have, and a collection of functions for manipulating them. So you need not write any code for that, only all the functions are available. You are only using it for getting your work done. It conducts mathematical and logical operations on arrays. What does it do? It conducts mathematical and logical operations on arrays. And the array object in NumPy is called ND array, n-dimensional array. What is that? We call a NumPy array as a n-dimensional array. What are the advantages? It provides an array object that is faster than the traditional Python list. And also it supports functions. Arrays are frequently used in data science, and NumPy arrays are stored in one continuous place in memory, unlike list. So they are stored in one continuous place. One continuous place, continuous memory locations. NumPy installation. Generally, if you're trying to import NumPy, let's say introduction to NumPy, you change the code to Markdown and run it. You'll have some text here. Then I would like to write a simple print statement to check the environment parameter. Welcome to NumPy. So run it. Are you getting yes? Our platform is ready and we can code for NumPy. If you're importing NumPy, import NumPy. And after writing this statement, if you're running, you're getting nothing. It indicates NumPy is imported. If you get an error, you need to, by default, actually NumPy is available. If you want to install NumPy, you need to say pip install NumPy. If you want to install, but here we succeeded in importing NumPy, so we are not running pip install NumPy. Fine. So NumPy array. A NumPy ND array, n-dimensional array object can be created using an array function. What is that? Array function. So here we go and create a simple NumPy array. So NumPy array, I import creating a NumPy array. Import NumPy as NP. NP is the alias name I'm giving to NumPy, so that we refer to NumPy using NP only. In this context, NumPy is no more existing, only NP is existing. With the help of alias name only, you'll be able to identify. Right? And I'm taking a variable ARR array is equal to NP is a NumPy alias name, over which I'm calling the function array. Array is a function related to the NumPy, to which I'm providing the list of values. Okay. NumPy is an array to which I'm providing list of values. Array takes list of values and converts it to a NumPy array and will be stored into the array. When you're trying to print array, you will be able to print array. And when you try to get its type is a function which takes the variable ARR and gives what type of data is associated with the array. So I'm running the code. You can see list of values is converted to a NumPy array, which is an n-dimensional array. Can you see? When I'm trying to get its type, it's an n-dimensional array. I want you to put your hands onto the keyboard, complete the demo. You try taking different values and post me the output. This is the first activity you need to do, which is a mandate to understand whether you are ready with the environment and able to perform the hands-on activity. As it is simple piece of code, if the lines of code is more, I would be posting you the code, which will really help you in taking the code from the chat and executing in the environment. And happy to see Varuni Rao and Sanju Bakchi has done with this. Only 4 participants has posted so far. Waiting for many more responses. I shall wait few more minutes if required, but make yourself comfortable to the first demo, which boosts your confidence and energy towards learning. If you have not understood, you please let me know. I'll make you comfortable. Yes, I can see Sumit Ranjan also has done. Very good. Only 5 participants so far. Afila Sultana, Ashish Balsam, James, Sumit Ranjan. Sumit Ranjan has done, sorry. Vaishali, Vinayak. How are you doing? Please respond yes or no. In 1 more minute, we'll go ahead with the next demo. Next demo is all about creating multi-dimensional. Okay, good. So creating a 0-dimensional array. I'm taking a variable array 0 is equal to np.array, and I'm giving a single value to it. I would like to print 0d array is and array 0. Let's see how it looks like. A single element, 0-dimensional array. Yes, 0-dimensional array will have only one element. You are good. Good observation. Next, I would like to create a 1D array. Array 1 is equal to np.array of 2, 3, 4. Print 1D array is array 1. Now I'm running some 1-dimensional array. Just now we created, no? It is also a 1-dimensional array. Array 2 is equal to np.array of, I would like to take 1, 1, 1 and 1, 2, 1. But I would like to take, can anybody say me quickly what is it? I'm selecting it. I want you to tell me what is it. Here it is a list, right? And what we call it as? Are you getting? 3-dimensional array is a combination of 2 2-dimensional arrays. Here you can see 0-dimensional array is having only one element. 1-dimensional array is having a list of values. 2-dimensional array is having list of lists. You have 2 square brackets, right? So 2-dimensional array is having 2 square brackets. 3-dimensional array is having 3 square brackets. And 3-dimensional array is having 2 2-dimensional arrays. Can you see? This is one two-dimensional array. And here is another two-dimensional array. So combination of two two-dimensional arrays is giving you a three-dimensional array. I would like to share you the code initially, as many participants may not be able to catch up while typing the things and getting the demo done. So to make you comfortable, not for everyone who is not very much comfortable, I can help you take the code from the chat window and run the code. Initially feel comfortable. Later, over a period of time, by spending enough time, ample of time, by performing the hands-on activities, you can make yourself comfortable. Post-learning, post-session, you can do that. Fine. So even for this also, I'm expecting the responses from you. I shall wait here. We are done with the introduction to NumPy. We shall go for the next subtopic in NumPy. So instead of always moving, I'm pulling two sub-lessons into the practice labs. And here is the attributes and functions in Python. Hope we are good to move for the next. When it comes to attributes and functions in Python, attributes of NumPy array and the functions of NumPy array we will discuss. Attributes, you can see few common attributes of NumPy are listed here. First one is array endim, then shape, size, data type, item size, and data. These are the 6 attributes we have. One after the other we'll see through an example now. What does it give you? Shape of the array. ARR dot over the array I'm calling shape, it will give me the shape of array ARR. What is the shape? We had a discussion in the earlier example. You are right, Varni. It is 2 rows, 3 columns. 2 rows, 3 columns. Fine. Next, you want me to zoom it? Yeah. Is that okay now? Comparatively, it's fine, right? No. I want to look at the attribute size. What does size of array gives you? Any guess? Size of array. Simple. Number of elements. How many number of elements do we have here? That's it. It gives me number of elements as 6. So before we proceed, I am running this. Can you see? Number of dimensions is 2. Shape of array is 2 rows, 3 columns. Size of array, number of elements is nothing but 6. We have 6 elements, right? Next, I say array stores elements of type array.dtype. What type of elements does it store? Very good. You're right, person. It is the integer type of elements. Can you see? Integer 64. how many bytes of data is allocated for one element of an array? Length of one array element in bytes. Array dot item size. So these are the array items. Specific item size I'm trying to get, so that will be the memory allocated for every element in the array. What is its size? It is 8 bytes. It is 8 bytes here. And finally, I would like to print arrays data. ARR.data. What does it give you? It gives you the memory location where the data is stored. Fine. I want you to perform this demo. Yeah. Okay, Divan? Yeah, going ahead. Attributes we have already discussed. So we shall look into the all explanation I have given you. Later we'll move forward to the NumPy array functions. We have transpose, reshape, and flatten. What does reshape do? It is used to reshape, giving a new shape to the current elements of the array. Right? Let's say I want to convert. Example, converting a 1D array to a 2D array. Array equal to np dot array of new array I'm saying is equal to over the existing array I call reshape. What is that? Over the existing array I call the reshape. When I call the reshape, what happens? It will reshape to the given size, like 4 comma 3 I say. Can anybody tell me what will be the shape of this array? Okay. So I can see the responses. Very good. Very good. Very good. 4 rows, 3 columns. Let's check whether it is reshaped or not. I am trying to print the array, and also I am trying to print in the new array. Can you see? This is the given array. This is the converted array. How many rows? 4 rows and 3 columns. First column, second column, and third column. So reshape function is converting the required shape. So likewise, let us look at the flatten. What is flatten doing? It returns a copy of the array flattened into one-dimensional. If you have a three-dimensional array, so to save time, I'm taking this three-dimensional array. Array equal to, or array 3D equal to, array 3D equal to np dot array of, I'm taking the 3D array. And I say flatten array is equal to array 3D dot simple, I call flatten. Flatten is a function which will convert any dimension to one dimensional. So you can print flatten. Can you see? A 3D array has been converted to. So I'm creating the document in such a way, it will be really helpful to you in next learning after days. Flatten. Did I give you the code earlier? Reshape? No. Yes, I have given. So I would like to give you the code related to flatten as well. Again, the flatten array can be reshaped. How you can reshape? You can call flatten array dot reshape. Whatever the shape you want, you can reshape. Okay, if you're looking for if you're looking for converting it to the original shape, what you can do? I'll do that. Print flatten array dot reshape of. So in the early session, we have been discussing NumPy arrays, how to create an array, how to create a single dimensional array, multi-dimensional array, and two-dimensional, three-dimensional array, and how to reshape an array, how to flatten an array, how to transpose an array. So these were the different things we have been discussing in the early session, right? I would like to rename the file day 2 NumPy and Pandas. NumPy arithmetic and statistical functions. We have arithmetic operations using NumPy like addition, subtraction, multiplication, division, and power off. In addition to that, we also have statistical functions of NumPy, like for calculating median, mean, standard deviation, and variance in the array. Also calculating percentiles and string functions in NumPy. Arithmetic operations using NumPy. We have two arrays. I would like to perform addition. Okay. So let's take this example. Arithmetic operations. Please let me know if I am not comfortable with the pace arithmetic operations in NumPy. I'm taking two arrays. Import NumPy as NP and A equal to NP dot array of 10, 20, 30 and B equal to NP dot array of 30, 20, 10. Then I would like to perform addition. So in order to perform addition, what is that we are using here? Add is the function we are using, right? So result equal to NP dot add. of I'm passing array A and B to the add function so that it will perform addition of both the arrays. And here respective elements will be added, index related. See, 0th index element will be added to the 0th index, first index element will be added to the first index, likewise. And finally, I would like to print the result. You can see what is the result. Power, I missed R. Can you see what is happening? A to the power of B, 2 to the power of 2, 2 to the power of 3 is 8, 2 to the power of 4 is 16. Likewise, you are getting 2 to the power of all B's. Can you see now? Yeah, sorry. Is that fine now? So we were performing power operation for all the elements. So A to the power of B, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, likewise 2 to the power of 6. 2 to the power of 6 is 64. Final objective is to make you comfortable. If the page is not comfortable, if you're not able to switch between the windows, understand the explanation, I recommend you to please respond immediately, which is really essential. Now it's time for us to discuss about the statistical functions. What is that? Statistical functions. No, it may not work. It may not work. Okay. It should say, for example, I'm taking here unequal size. Is it working? No. So equal number of elements should be there for both the arrays. Basamdevan, are you comfortable? Is that okay? Let's look into the statistical functions in NumPy. So I would like to calculate mean, calculating median, mean, standard deviation, and variance in array. So median. Array equal to np dot array. I'm taking the elements 4, 3, 2, 10, 1, 0, 5, 8, 4, 20. Right? So what dimensional array it is? Can anybody tell me? What is the dimension of the array? What is the dimension of the array? NP dot median of array I'm saying. What will be the median? Can anybody tell me? What will be the median? Two-dimensional array. Ashutosh, it is a two-dimensional array. It's not a three-dimensional array. Very good. Sakti Pandyan and Sandhya Rani has given the right answer. Yeah, median is a middle value, right? Median is a middle value, but you need to arrange them in an order, ascending order, right? After arranging them in ascending order, getting the middle value is the median. So shall we arrange them in ascending order? Let's arrange them. Here, see, I'll arrange them in ascending order. It is starting at 0, 1, then 2, 3, 4, 5, then 8, then 10, then 24. How many elements we have got? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I am trying to get the middle element. I am removing right 4 elements. I am removing right 4 elements. I am removing left 4 elements. And here you will be getting a middle value, which is a 4. So 4 will be the median. Have you got the concept? 4 will be the median, middle value. Next, I would like to print this in the print. Median. Then I would like to calculate mean. For calculating mean is nothing but an average. NP dot mean of array. I would like to print it. What are the calculated value? I would like to print it. What does it mean? Sum of all these values by number of values is my mean. Right? Likewise, standard deviation. Print NP dot standard deviation of array. This is standard deviation. And also variance I would like to find. Variance. Print NP dot variance is a function which will take array values and give you the variance value. So that is the variance. Getting? So you might be knowing what is a median, middle value. What is a mean? Average. Let's calculate the average also now. I'm opening the calculator. You can see. I'm adding 4 plus 3 plus 2 plus 10 plus 1 plus 0 is not required, plus 5 plus 8 plus 24 equal to so and so, divided by 9 elements, right? 9. How much is the value? Are you getting the same value here? 6.33. Same value we are getting, right? That is the mean. What is the standard deviation? Standard deviation all about how much each and every value is deviated from the actual mean. See, 4 is divided. 4 is deviated 2.33. 3 is divided 3.33. 2 is divided 4.33. Likewise, these deviations, it is going to calculate that standard deviation. And you can see the formula for standard deviation. Formula for standard deviation goes this way. Can you see? Square root of the variance is nothing but standard deviation. Sigma of xi minus mu. Xi is nothing but in this context. Xi is nothing but in this context. Every individual value. It would be 4, it would be 3, it would be 2. So it's calculating 4 minus 6.33 plus 3 minus 6.33 plus 2 minus 6.33, likewise every value it is subtracted, and whole squared by n under root is nothing but a standard deviation. You can calculate, you'll get the same value. Right? Next, variance. Navin Raj, Manish, Manshi Bharadwaj. Variance is square of 6.99. Can you see? See, calcium taking 6.9 6.9442 square. Are you getting 48.22? So standard deviation square is nothing but variance. Manshik, are you comfortable now? Now let's go and calculate percentiles. Calculating percentiles. Here, np dot percentile of array comma 50. What is the 50th percentile of an array? This is an array. When you arrange in an order, what will be the 50th percentile of an array? 50th percentile of an array is nothing but median. Always remember there are 3 quartiles. If there is a data point, the data points are divided into 2 quartiles with the help of Q2. 2 quartiles into with the help of Q2, we call it as median. And the left half is divided into 2 halves again. 2 halves again with the help of Q1 quartile. Here, this side will be the 50% of the data, and the right side will be the 50% of the data. Okay. And Q1 is dividing this 50% into 25% and 25%. Likewise, you also have a Q3, which is dividing the remaining of to 25 percentile and 25 percentile. So by this, what you came to know? There are 2 quartiles. There are 3 quartiles, sorry. What are they? Q1, Q2, and Q3. These 3 quartiles are dividing your data into 4 equal parts. And Q2 is called as a median. Q3 minus Q1 is called as interquartile range. What is that? Interquartile range. In this interquartile range, 50% of the data will sit. In this interquartile range, 50% of the data will be residing. You can see 25 plus 25, 50%, right? So 50% of the data will be residing. That is the understanding. So percentiles, the quartiles will come into the picture. You have 3 quartiles, Q1, Q2, and Q3. Q2 is called as a median, which is dividing the entire data into the 2 equal parts. And Q1 is dividing the left half into the two equal parts. Q3 is dividing right side into the two equal parts. Q2 is called as a median. Q3 minus Q1 is called as the interquartile range, where 50% of the data will be residing. That is our understanding about the percentiles. Any doubts here? If you want to generate the sales report, like I want to find out 50th percentile salary is the amount at which half of the employees earn more than and half than less. Right? When you get 50th percentile of the salary, you'll get into a conclusion 50% of the employees will earn less than this salary, and remaining 50% will earn greater than the salary. If you test some score and it is in 90th percentile, what you say? You score better than 90% of the students. When a particular person score is 90 percentile, you can say you scored better than 90% of the students. That's how we differentiate in the real life. So I have taken two arrays. They are string arrays. I would like to perform the concatenation. If you want to perform a concatenation, you have a function called as char. Under the NumPy, you have a function called as char, under which you have an add function, which takes two arrays and add them or concatenate the respective index elements and will give you the result. What is that? Hello will be added to welcome, bold will be added to the learners, and you will be getting the respective result. Can you see? What is that we are doing here? NumPy contains a character which contains a function add, taking array X and array Y and printing is the result. So if you want to generate an email, with the combination of first name and second name, or first name and last name, combined with @company name, this would be useful. Or if you want to create a URL, or if you want to label the data, adding the prefix or suffix to the existing data, this would be useful. If you want to add some spaces, you can add here. Can you see? I'm adding some spaces here. And later I'm running the code. You can see there is a lot of comfort. Hello, welcome, world learners, right? Some space is good. And I would like to replace. How do you replace? I'm saying np.char.replace. Over the char class, you have a replace function which takes the string and replace in the string hello with hi. Hello with. I would like to store the replaced string, the new string into the set so that I can print the new string. Can you see? This is the old string where we have used a char dot replace of string. We are passing the original string, and in the original string, I am replacing hello with hi. So replace is taking three parameters: string parameter, the old string, and a new string. The entire text with the old string and a new string, so that the old string will be replaced with the new string, and the updated string is stored into z, and I'm printing that z. Can you see? That's how it's functioning. And next is all about, I would like to discuss. So replace is all about, in Word, you will find and replace, right? Control F, you'll find a particular text and try to replace with a new text. Here is a very interesting example related to replace. I would like to discuss one more example. I have names is equal to np dot array and updated I would like to is equal to np dot char dot replace. So I would like to replace all the names. All the names contains Mr. right? I would like to replace the Mr. with doctor. Now it's all about indexing. Indexing, you have accessing elements in a one-dimensional array, two-dimensional array, three-dimensional array, and native indexing also we have. NumPy array is providing you indexing. Indexing allows you to access the array elements using an index value beginning from 0. We have three arrays, three-dimensional arrays. So let me take this array. To save some time, I'm taking this array. We have three-dimensional arrays. One-dimensional, two-dimensional, three-dimensional. Now I would like to access and I would like to print the value of index 3. One-dimensional array, I would like to print the value of index 3. So print array underscore 1D of 3. So can anybody tell me what is the value at index 3? That is really important. Your interaction makes more value. I have a three-dimensional array, one-dimensional, two-dimensional, three-dimensional, and we are working on one-dimensional array. Yes, you are right. I've got a few responses from Manshi and Partha. See, index is starting at 0, 0, 1, 2, and 3. At third index, you have the value 4, right? Can you see? And also, I would like to perform addition of index 0 and 1. How do you perform index 0 and 1? Print array 1D of 0 plus array 1D of 1. So what does it give you? 0th index plus first index. It is a 3, right? So I recommend you to please run the demo. So add function, no, we cannot use add function because add function is used to add two different arrays. But here we are adding the same array, different index values. And we perform it using indexing only. Accessing to the array elements. I would like to print a third element of the first row of a 2D array. What is that? Print the third element of first row of 2D array. Third element of first row. What is the third element of first row? This is the first row and this is second row, right? What is the third element? This is the third element. How do you print? How do you print? print third element of a first row. Vernero had worked. Like, how did you use it? Oh, let me see. The response. Okay, okay. Of course. Yes, I will work this way. No problem. No problem. Good, good. Happy to see your response. That's really a interesting learning. And can anybody tell me how to get second element of second row? Second element of second row. Here. Second element of second row. In the second row, say this is 0th index, this is a first index. And again, its index is starting at 0 and 1, right? 1 comma 1, right? Yes, yes, you're right. And please, participants, try to understand. I'm trying to take you through a very simple and comfortable learning journey. And if you're asking me to very slow down the learning, we have a lot of things to be catch up that would really complicate our learning. At a very basic beginning stage, if your learning is at a very snail pace, that would really impact your the whole learning. These are very simpler things. I recommend you to stay tuned with the see 1 comma 1. What is that 1 comma 1? 5. First row. This is the 0th index row. This is the first index row. And in the first index row, I am targeting first index element. And I am getting 5. Can you see? That is how I am accessing the two-dimensional elements. And how to print that element? Print array reading of x corresponds to x element, right? So first element. And y is corresponding to yth row. Yth row is nothing but first row. And zth column, first column. What are you getting? What is that you are getting? 11 you are getting, right? But this is not the element you are trying for. What is it you are trying for? First element of the second array. This is the second array, first element. Now, can anybody tell me what could be the values I can mention here? One zero zero. Okay, let's see. Ah, you are right. 1 0 and 0. You are right. Are you getting 7? Yeah, you are right. It's really interesting to see the response from you. Now it's time for us to discuss about the native indexing. Native indexing. As you know, native indexing is counted from the end of the array. And in negative indexing system, the last element will be the first element with an index of -1. And the second element will be the index with -2 and so on. I want to print the fourth element of the 1D array using negative indexing. Print array 1D. Fourth element. How do you get the fourth element using negative indexing? Here we have 1, 2, 3, fourth element, right? Fourth element, I can say -1, -2, and -3, right? So when I say -3, I'll be getting fourth element. -3. Can you see? What does this indicate? You have a two-dimensional array in which I am targeting second array. What is that? Second array. What is the second array? This one. This is the 0th index array. This is the first index array. So I am mentioning one in which -1 I am saying. So I would be expecting a -6 as the output, right? So am I getting a -6 as the output? Yes. That's how it's functioning. Okay, is that fine? Of course. One problem, multiple solutions. Partha, you have one problem, multiple solutions. Even this way also it will work. And I want to print the last element of 3D array using native indexing. Print array 3D of 1, 1, -1. Say, let's see what is it going to print. 1, 1, -1. See, here you have three-dimensional array, right? 1 means this is 0th index array. This is a first index array. So it is referring to 1, in which you have 1 and -1. Sorry, in which you have this 0 and this 1, right? Let me write. This is a 0th index. And this one is a first index. In which you have again, in the first index you have again 0 index and first index. What I said? 1, 1, -1. So 1 is referring to this one. Next one is referring to this one. And -1 is referring to the last element. -1. Hence you will be getting 12. Let's run and see whether we are getting the desired result from it. Are we getting? Yes. Hey, sorry. Whatever you have mentioned, coming to Partha, coming to Manshi, and Sekti, even Navin Raj, yeah, everyone is right. We are trying to get the elements from first index to 7th index. So what is the first index? First index is 4. 7th index, but 7th index is not inclusive. So we'll consider till 6th index. Or you can consider the other way. What is that? 7 minus 1 is 6, right? All together you'll get 6 elements. 1, 2, 3, 4, 5, 6. You'll get 6 elements. You're getting the same 6 elements, right? That's how it is going to function. Slicing. I would like to slice. I'm taking a books is equal to np.array of I'm taking some books, physics, data science, maths, Python, Hadoop, Oops, Java, and the cloud. So you can break it. Yeah. This is a list of elements, array of elements. I'm saying books of 5 column. That's it. What does this indicate? Starting from 5, what is the 5th index? 0, 1, 2, 3, 4, 5. So starting from 5 till end, if nothing is given at the end, it will consider till end. So from 5 till end, it is going to print. Is that okay? Shall we continue? Slicing using step value. Hope everyone is aware of x equal to np.array. And I'm taking an array like 8, 7, 6, 5, 4, 3, 2, 1. Right? Then I would like to print x of 1, 6, 3. What does it mean? 1 to 6. Let's say index is starting from 1 here to 6. What is the 6 index? 1, 2, 3, 4, 5, 6. So 6 is not inclusive, right? Till here only. From here till here, the step of 3 means 7. After that, what is the next step? 3 plus 3. 7, 6, 5, 4. 7 and 4 will be the output. What is that I'm expecting? Let's run and see what is that output. Yes. So 7 and 4. Step index at a step of 3. Yeah, definitely. That would be really pressure for me. If you ask me to explain again, yes, I am ready always. See, starting at first index, right? This is 0th index, this is the first index, right? First index starting. Ending index is 6th index. So 1, 2, 3, 4, 5, 6. But 6 is not inclusive, right? 6 is not inclusive. So I am considering till 12. And at a step of 3. Step of 3 means it is a first index, right? First plus 3. 1 plus 3 is 4, right? 1, 2, 3, 4. What is the 4th index value? 4. 7 and 4 will be the output. That's what you are getting here. Are you comfortable? Slicing 2D array. slicing to the other. Z equal to np dot array of 11, 22, 33, 42, 55, 66, 77, 88, 99, 110. And I'm saying, hey, sorry, 1 second. I would like to change this. np dot array. Yeah. Now I would like to print a z of 0 colon 0 comma 2 colon 2. What does this indicate? 0th index. What is 0th index? This one. In the 0th index, starting at second index, 0, 1, 2, second index, right? And indicate third index. What does indicate? It is targeting 33. That's it. Once again, you have two indexes. What is that? In it's a two-dimensional, right? This is the first dimension, 0th index dimension. This is the first index dimension. So here I mentioned 0th index dimension. And I'm saying 2 colon 3. In the 0th index dimension, I'm targeting second index 0, 1, 2. 2 to 3 I'm saying. 3 means 2 to 3 means nothing but 3 minus 2, 1 only 1. That is 33. Now I want 1 second. Z is uppercase here. Now I want you to help me in printing 77. I want you to help me in printing 77. I am waiting for your responses. Folks, please go ahead. I want to print 77. I want your responses here. Okay. So I'm right away putting the responses you have shared me. Z of 1 colon. What is that you have shared me? 1 colon. 1 comma 1 colon 2. And you'll be getting 77. Yeah, very good. Very good. Very, very happy. Sakti, Varuni, Partha. Now, as I am explaining you once again, please listen carefully. See, this is a two-dimensional array, and I am considering this as 0th index. And I am considering this one as a first index. And here I am saying, while slicing, I am saying Z of 0. 0 is referring to whether it is referring to the first array or the second array. And out of which I am trying to slice, right? Can you see? This 2 colon 3. This 2 colon 3, if it is 1, it is applied here. If it is 0, it is applied here. And so 2 colon 3, you are getting 33. And when I say 1, it is applying here. 1 colon 2, nothing but 2 minus 1, 177 you are getting. First index value. Is that clear? Namita? Sorry. And all other participants, are you comfortable? Please let me know. Actually, for today's session, if we go at a normal pace, very normal pace, we would have started the pandas part and completed almost 20 to 40% of the pandas. Understanding? So we are taking the session in a very, very snail pace. The only reason I want to make you comfortable. And we need to improve this pace. Please think of it, start working on it. Right? No, it's all about slicing 3D array. Slicing 3D array. I'm taking array 3D is equal to np dot array of 1, 2, 3, 4, 5, 6. Then 7, 8, 9. Hey, 1 second. 10, 11, 12. It's a 3-dimensional array. What is that? A 3-dimensional array contains two-dimensional arrays in this context. I would like to print array. I would like to print array 3D of 0, 1, colon, 1, colon. What is it indicating you? I am targeting 0th index. What is 0th index? This one. In which I am targeting again first index. What is the first index? This one. This is the first index. 0th index. In the 0th index, we have 0 index and first index. In the first index also you have 0th index and first index. But I am targeting 0th index, first index and first index. So this is the first index in which I am targeting first index. So 1 colon means 5, 6. It will display me 5, 6. And I want you to tell me, I want to print 11, 12. What could be the slicing for 3-dimensional array? What kind of notes? See, what are the handouts are there with you? The slicing, Manshi, I will respond to you. Just let me clarify Partha's doubt. Partha, you have a lot of handouts given to you, right? Like slicing, you can see. You have a lot of things given, right? So you try to document them, that's it. That would be enough. And indexing you have, try to document. Only important points you try to document. Okay. We are discussing slicing 3D array. And I want to display 11 and 12. Can anybody give me the inputs? Okay, let me see. What are the inputs that are given by the users? The participants. I am giving here array the 3D of 1, 1 colon, 1 colon. Yes, you're right. You're exactly right. You're on the right track. I'm happy to see you all. Manshi, Sanju, Any doubts, let me know. I'm sharing the code in the chat window. Are we good to proceed to discuss the introduction to pandas? Can you please confirm me? It's a new library. So pandas, fundamentals of pandas, we'll be discussing purpose of pandas, features of pandas, data structures. Like you have two different data structures which are very important. As of now, in the introduction part, we'll be discussing only series part, but we also have a very important data structure called as data frame, which will model the data in the form of rows and columns. That's really very beautiful. Well, you'll get to know over a period of time, but now fundamentals of pandas. Pandas is an open source library built on top of NumPy and is used for data manipulation. It introduces the data structures like data frames and series that make working with structured data more efficient. We have different purpose of pandas, features of pandas, and data structures. Let's look into the introduction to series. When it comes to the series, okay, sorry. When it comes to the series, we are going to create and access pandas series using the different methods. So hope we are good to go ahead. Creating and accessing pandas series using different methods. Using different methods. Fine. So as I told you, pandas contains two data structures. What is that? Series and data frame. So series is a one-dimensional. Data frame is a two-dimensional. Data frame contains the data in the form of rows and columns. And now I would like to create a series initially. Later we'll go to the data frame. Import pandas as PD, where we'll be using the pandas. Then I would like to create a pandas series from a list. I am taking data equal to 1, 2, 3, 4, 5. And I would like to take the series is equal to PD dot series of data. So next, I would like to create a pandas series with a specified index. Folks, please try to understand. We have imported a pandas as PD. We have taken a data and I'm converting into data to the series. Okay. Now, creating a pandas creating a pandas series with a specified volume. I'm taking index equal to A, B, C, D, and E. And I would like to also take series with index is equal to P dot series of data comma index equal to index. Then creating a pandas series with a specified folder. This is very important step. So I'm taking data dictionary is equal to creating a pandas series from dictionary. Data dict equal to, I say A colon 1, B colon 1, 2. C colon 3, D colon 4, E and E we have colon 5. I would like to create a pandas series. This is a one-dimensional, okay, from a dictionary. So we have series with index. We have taken creating pandas series from a dictionary. I have taken the data, and what I do, series from dictionary is equal to field dot series uppercases and data comma index equal to index. So we are creating a pandas series from a dictionary with the help of the data we have. Later, I would like to create a series from a dictionary. Let's say index equal to A, B, C, and D. Okay. I have four values I have taken. Out of which I'm trying to get We have created a panda series from a list, and I'm trying to create a series is equal to period or series of data. So we have a two-dimensional array. This is a data series, and series with index, series from dictionary, and finally from dictionary. So let's forget this one. Creating pandas series. So creating panda series from dictionary. So I'm taking index equal to A, B, C, D, E. I've taken a panda says from a dictionary. Index is mentioned. So whenever you're giving an index and then saying select with index is equal to pd dot series of amount comma index equal to index. Later I'm creating a pandas series with a specified field. So if you want to create if you want to store the series, pandas related series or a creating a series, you can create it from a dictionary. Data underscore dict is equal to A colon 1, B colon 2, C colon 3, and finally D colon 4, and E colon 5. This is a dictionary. So data dictionary equal to so and so. Select from dictionary is equal to pd dot series of data underscore. So I would like to print series 2. And I would like to also print series with index of P. Let us run and visualize. Invalid syntax, delete colon, 4. Can you see? Type error, 14 line. They said, like, I see. 1 minute, we'll end the session for today. Meanwhile, I'm trying to remove this error series from dictionary. Hey, yeah, indexable index, right? Okay. And later, amount is not defined. So this is our last demo. Now, if any error is coming, we shall rectify it. Amount is not defined, saying where is the amount here? Select with index, filter series of amount index equal to index. No problem, we shall clarify it later. That's really challenging. If you can clarify, if you can resolve the error, that would be really great. You work on towards resolving the error. I shall also work on it. Meanwhile, I would like to know how was the today's session, folks? How was the today's session? I'm converting the document to the PDF. Can you please confirm me? How was the today's session? Actually, today we were going at a very, very snail pace. Slightly, I would recommend you to support me in improving the speed. Hope you understand. And I would like to download the file from the cloud, the practice labs. Anyways, if you can fix it, you fix it. Otherwise, I shall fix it later. Okay. And I'm downloading the file where I can share it onto the LMS. Excuse me, can you please respond? How was the session today? And I would recommend you to please submit the feedback and respond to me in the chat window as submitted. And I'm uploading the today's file, day 2 number. So if you want to access a specific data from the series, we have created a series, right? Print series of, when you say 2, what is the value available at the second index? Can you see there? In the series, what is the second index value? 0, 1, and second index, right? 3. You will be getting 3. Series with index of, I say 2. No, I say index B. Because A, B, C, D, E we have given, right? Indexes. This one. Series with the index. Series with index. At B index, what is the value available? 2. So you will be getting 2. Hope you are getting any doubts. I would like to discuss a very realistic example. I take months is equal to Jan, Feb, March, April, May. Right? Revenue, I would like to say $1,000, $1,500, 1,700, 1,600, and 2,000. Right? And the revenue series is equal to, we have been discussing introduction to pandas. So we shall look into we have seen all this. We shall look into the basic information in panda series. Right? Basic information in panda series. Like tail, head, shape, describe, and unique and unique. Basic information. I would like to get first n rows is equal to series dot head of 3. So what is that you are getting? First 3 rows you are getting, right? Similarly, last n rows. Last n rows. What does it give you? Series dot tail is a function which will take the n number and returns you the required number of rows from the last. Last n rows. You can see. Do you want even this 1-2 lines code also? Later, I would like to get the dimension. So dimension is nothing but row comma column. Dimension is equal to series dot shape. What is again? It has 5 rows, is the meaning. It has 5 rows, is the meaning. So to generate the descriptive statistics, generate descriptive statistics. Stats is equal to series dot describe. What does that give you? It gives you count. It gives you mean, average value, standard deviation, minimum, maximum, and interquartile ranges. So that's what descriptive statistics it is giving you with the help of describe function. And later, unique values is equal to series dot unique. Unique values. Can you see? All are unique values only. Returns unique values. I want to find out number of unique values. In a series, you might be having a lot of values, and out of that, I would like to find out number of unique values. Series dot n unique. You see, 5 unique values we have. Hope you are getting what we are doing. For example, you want head, is that right? Head is giving top 3 values. What does it mean? If you want to view top 3 transactions performed recently, recent 3 transactions, yes, can make use of a head. Likewise, survey data you want to analyze, yes, you can analyze, and you want to know how many fields are there, like what are the rows, what are the columns you have, you want to analyze. Then you can go with shape. If you want to get the total analytics over the results data, you have exam results data, and you want to get average score, highest score, and how scores are spread out. Yes, you can use describe. And unique, if you want to get the unique values, or let's say in a system there are different roles available like system admin, user, guest. So I want to view the different roles available, and you can see with the help of unique. And there are a lot of records, out of which I would like to find out how many different city people are there in the data. There are some certain employees available. So let's say 1,000 employees are available. I would like to find out to which different cities all these employees are available. So I can get unique, n unique, number of unique cities. So this way you can work with the different functions of pandas. Later, operations and transformations in pandas. So let's see operations and transformations in pandas. So what are the operations we have? Operations and transformations in pandas series are crucial for modifying, enhancing, and cleaning data efficiently. They provide flexibility to adapt to the data to specific analysis or visualizations, preparing it for meaningful insights and ensuring data quality. So if you want to perform some kind of analysis over the data or do some visualizations and prepare some meaningful insights, then it is useful. So we shall see element-wise addition. Element-wise addition. Result series is equal to series plus series with the index. Result series, right? And you can see what is it available? It is showing you NA. Why? Because when you are adding series, when you print series separately, yes, you will be able to print. When you are printing series with index, you will be able to print. But these two doesn't have any common indexes. Hence, addition is not possible, and you are getting not enough, not a number. If I want to apply, a function to each element, apply function to each element. Let's say I have a series of values. I would like to square each value. So squared series is equal to series dot apply of lambda x colon x to the power of 2. And I'd like to print squared series. So you are getting squared series. Earlier was 1, 2, 3, 4, 5. Now squared series, we have applied a lambda function over each and every element. You are multiplying it to x square you are doing, right? X into x. And you are getting 1 into 1, 1, 2 into 2, 4. Likewise, you are getting all squared values. Instead of one value, only 1 is getting displayed. Instead of 2 value, TWO2, likewise 3. And 4, 5 I didn't mention, so it is giving you NaN. So this way we can map with the help of map function by mentioning a dictionary. Instead of 1, I am asking it to display only1. Instead of 2, I am asking it to display TWO2, likewise 3. This way we can create a mapped series with the help of a dictionary. I was expecting some outputs. Are you doing? I would like to sort the series by values. Sort the series by values. Sorted series is equal to series dot sort values. Generally, if the series is not in a sorted order, it will sort and display it. Actually, we have taken a sorted series, hence no effect is seen. That's it. Hope everyone is following. If you want, these all are 1, 2 lines demos and the very simpler ones. And hope you are comfortable following. And how to check the missing values? Check the missing values. So missing values is equal to series dot is null. Print missing values. Can you see? None of them is missing values. If anything is missing value, you will get it true here. No? Everywhere you have values. There is no missing values here. If you want to handle if you want to handle missing values, what you can do, I would like to fill missing values with a specified value. Filled series is equal to series dot fill null value with 0 is the meaning. And I can say filled series. So anyways, we don't have any missing values, so it will not fill with any zeros. But this is the actual process to fill the missing values. And this is the actual process to get the missing values. Okay. I shall wait here 1 to 2 minutes to make you comfortable before moving to the next section. So if you want to visualize these series transformations in a tabular format like Excel, we can convert them to the data frame and view them side by side. You can confirm me. Yeah, Sanjay Bakshi, your indexes should match. Then you can add. Sanju, did I clarify your doubt? Varni, are you comfortable? Okay, great. So moving ahead. Next is all about querying. Querying a series. Querying is all about selecting and filtering data based on a specific condition in an essential aspect of querying a Pandas series. And you can see some demonstrations here for querying operations. We shall take this Pandas series. I'm taking this Pandas series. Querying series. This is a Pandas series. If you want, you can check out the series. Right? This is the series. What I would like to do, I would like to see. I would like to get the elements which are only greater than 30. So select elements greater than 30. How do I do? Simple. I'm taking a variable selected greater than 30. Series greater than 30. Can you see? You'll be getting only over the series. I'm querying saying that series greater than 30. What's happening? It is only selecting the series which are greater than 30, like 40 and 50. And you can see you are getting only 40 and 50 as an output. So I would like to give you the series, actual series, over which we are querying now. Okay. All of you complete it and post me the output. I shall wait here 1 minute so that we'll query few more things. Meanwhile, I have one query to be done by you. Selected equal to 20. So how do you do this? By referring to the above one, you try to do this. And only based on your inputs, I'll be posting the response here. That's it. Sanju has given the response. Also, Manshi has given. I'm taking the Sanju's response as it is the first one. Let me put it here. Now let's see. Except 40, all other are 20. Right? Now I'd like to get select elements based on multiple conditions. So I want to select the elements based on multiple conditions. Select multiple conditions equal to series of series greater than 20 and series less than 50. So can you tell me what will be the output for this particular multiple conditions? I am trying to print the select multiple conditions, and I am looking forward what would be the output for this one. Can you please check the condition once again and answer? Series should be greater than 20, less than 40, less than 50. Very good, Sanju. 30 and 40 is expected. Let's see. Are you getting 30, 40? Yeah. I would like to select elements based on a list of values. Select by list is equal to series dot is in of printing 4060. What is expected? It would give you those elements matching these list elements. Oh, method, what is the method? So is in, okay, this one has open close parenthesis. Can you see? So 20, 40 is existing in the actual series. 60 is not existing, so ruled out. Only those elements which are matching with this list are getting displayed from the series. Yeah, sure, with pleasure. See here, is in series over a series. What is the series? Series is having the values. Can you see? These are the values I have defined for the series. 10, 20, 30, 40, 50 with the A, B, C, D, A's as indexes. So over that series, what I'm saying, series dot is in function to which I'm passing a list of values. If these list of values are there in the list, then it gets displayed. See, at index B, you have a 20. At index D, you have 40. But 60 is not there, so it is ignoring. So that way, is in function is taking a list of values and verifying with the series values. If it is matching, the matched list of values are stored into a select by list variable. And I'm displaying the select list. Let's create a series now. Series is equal to the list of values I'm taking. 1, 2, 3, 4.5. Let's see what happens. I'm taking list of values. List 1. And I'm converting it to series. Dot series of data. List 1. Let's what? Hey, this series will be affected. Series 1, I say. Are you getting? A series can have mix of data types. So at the end of the lesson, you have an assisted practice. I recommend you to do this, get this done, okay? At the end of the you have an assisted practice. Problem statement. Using Panda series to analyze sales data for a retail store over a week and draw insights from the data. So we have this sample data, sales data, days of the week, and create a Panda series from sales. Use list daily. Okay. Whatever we have discussed, all are mapping with this requirement. So you simply relate them. Fine. Let's move to the next. Allocation is for slicing. Location is for indexing. Varney, you are right. That is understood, right? Yeah. Next, Pandas data frame. Very, very important Pandas data frame. Okay. In this, we'll be discussing creating a data frame using different methods, accessing the data frame, understanding data frame basics, and also statistical operations in Pandas, descriptive statistics, mean, median, and standard deviation, correlation analysis. First of all, we shall look at a Pandas data frame is a two-dimensional tabular data structure with a labeled axis. What is that? A Pandas data frame is a two-dimensional tabular data structure with a labeled axis. It contains rows and columns. It is a primary data structure in Pandas library, providing a versatile and efficient way to handle and manipulate the data in Python. So you see, for example, there is a student data like roll number, name, email ID, marks, percentages. So everything is organized in a perfect, efficient way. And also, if there is any missing data, or if you want to update any record, if you want to update the entire column, yes, handling the data is becomes very easy for us. Coming to the key features, the data frame is organized as a table with rows and columns, similar to the spreadsheet or SQL table. And labeled access. Both rows and columns are labeled, allowing for easy indexing and referencing of data. So you can point to any particular record or any particular cell and perform any kind of modification or accessing them. You also have heterogeneous data types. What are they? Each element in data frame can contain different types of data. Each column in data frame can contain different types of data, such as you can have an integers column, you can have floats column, string, or even complex objects. When it comes to versatility, say heterogeneous data type like, let's say, employee number is one type of data, employee name is another type of data, phone number is again another type of data, salary, currency, it's a floating point of data, right? Likewise, we can have different type of data. Heterogeneous data types can exist in a data frame. Versatility, data frames can store and handle a wide range of data formats, including CSV files. CSV stands for comma separated value files, and Excel files, SQL databases, and many more. Data alignment. Operations on data frames are designed to handle missing values gracefully, aligning data based on the labels. So operations on data frame are designed. We have some data operations which are designed to handle missing values and aligning the data based on the labels in an efficient way. So we shall look at the creating data frame using different methods. Data frame is a fundamental step in data analysis and manipulation. So diverse methods are available with Pandas to generate a data frame, addressing various data sources and structures. So if you want to create a data frame from a CSV file, yes, you can do that. If you want to create a data frame from a series, yes, you can do that. You want to create a data frame from a dictionary, yes, you can do that. And if you want to create a data frame from an Excel file, even Excel file also can do that. That is the beauty of data frame. Data, whether in Python dictionaries or lists or NumPy arrays or external files such as CSV and Excel, can be seamlessly transformed into a structural tabular formats by Pandas. That is the beauty. So here is a dictionary. Here is a dictionary I'm taking. Can you see? You can see data dictionary. Name is a key. List of values are value. Age is a key. List of ages is a values. Salary is a key. List of salaries are a values. Now what I would like to do, I would like to convert this data dictionary to a data frame. How do I convert a data dictionary to data frame? I am taking a variable data frame df underscore dictionary is equal to td dot data frame of data dictionary. What happened? Data dictionary is given to the data frame function where it is converting keys to the column names. Can you see? It is converting all the keys to the column names and values as a records. Values as a records. right? That's how a dictionary has been converted to a data frame. I want everybody to post me the output with the different values. You edit some values and post it. That would really give me some understanding. Once you're done, let me know. We shall create a data frame from a list. What happened? Simple. List of records. This is a list inside a list. This is one record, list of records, 3 records. And it is a list. I am passing it to the data frame with the columns equal to name, age, salary. So name is considered as allies, age is considered as 25, salary is considered as 50,000. The same order I'm following, right? And according, you change the order, again the data will be, the given order only will be displayed. For example, instead of age, I'm giving date of birth. Date of birth. So it's a wrong column name, but still, whatever is given is displayed. Fine. So giving a proper column name. So we have created a data frame from a dictionary, data frame from a list, right? I would like to create a data frame from a NumPy array. So we shall look into creating a data frame from a NumPy array. Here is a NumPy array. Can you see? Creating a data frame NumPy. Same data is same within the square brackets, but only I have given it to a NumPy array. Later, df underscore array is equal to pd dot data frame of data array I'm giving. And also at the top, I have mentioned columns, right? The same columns will be columns equal to columns. Take to print df underscore array. Right? Same thing. Only array came into picture this time. That's it. Here you don't have array, directly list I'm giving. Here it is a list. Here it is a NumPy array. That's it. I'm ensuring that I'm giving you enough time for getting it done at every step. So please make yourself comfortable. Now it's time for creating a data frame from CSV file. Very important step. This is important for you. Creating a data frame from a CSV file. So I would like to share you the CSV file now in the chat window. All of you download the CSV file. I shared you in the chat window. And next, what you need to do? Simple. Download a file. You drag that file. All of you, please remember. I'm making the CSV file available to the current environment. So in order to make it available to the current environment, you need to just drag that CSV file and give it to the here I'm loading. You have folder, right? In the folder you load. Can you see? House prices.csv. House prices.csv. Please make sure that it is available here at your current folder. Then we shall get into the writing the code. Simple. df underscore csv is equal to pd dot read underscore csv is the file function. Read underscore csv is the function which takes house prices and you can print. Can you see? 4,600 rows with 18 columns are there, the data in this particular data set. House prices.csv. If you want, you can open that file directly. By default, it gets open in the Excel and you can look at the data. A lot of data is there, right? Can you see? A2 or 18 columns. And you can see when you scroll down to the last record, you can see 4,600 records are there, right? This is the date column. And I would like to read the data from the Excel file this time. Creating a data frame from an Excel file. df underscore Excel is a data frame variable I'm taking, onto which I would like to read the Excel file. pd.excel is a function. Read Excel. I'm giving iris dot Excel assets. Then I'm printing df underscore Excel. Oh, something went wrong. There is a typo. Can you see? You got the Excel file. So this way we can read the Excel file also. By this, what you came to know? We can create a data frame from a dictionary, from a list, from a CSV file and Excel file. Accessing a pandas data frame involves employing various methods for selecting and retrieving data, where it can be specific columns, rows, or individual cells. So we'll be utilizing the square brackets, iLocation function, location indexers, and conditions, where analysts can navigate and extract the necessary information from the data frame for further analysis and manipulation. The flexibility of pandas allows for both label-based and position-based indexing, offering a versatile toolkit for accessing and working with the data efficiently. So we have a data frame. I'm taking this data frame. All of you take this data frame. I'd like to give you no problem. What need? Data CSV file is already converted to data frame. When you perform pd.read CSV, whatever the data is available in the CSV file is converted to the data frame. And also, Partha, I'm not audible. Partha, am I not audible? You were saying assignment, right? The assisted practice for every lesson. At the end, you will have. For example, I'm opening lesson Introduction to Pandas. When I open Introduction to Pandas, you can see at the end, you'll have the assisted practice. Can you see? I wanted to get this done. And it is closely mapping to whatever we have discussed. If at all it is required, you need to explore a little bit. That's it. Not much. So we have taken this data frame. Actually, it is a data dictionary, right? I'd like to convert to a data frame. df is equal to bd dot data frame and of data. So when you're trying to print the data frame, you'll get the data frame. Can you see? All of you? Complete this one. So that we'll be accessing the data frame specific data. Here, accessing a single column. I want to access single column, like I have column name as a column 1, column 2, and another column. These are the 4 columns we have, out of which I would like to access column name. So column data is a variable I'm taking, and the data frame df is a data frame which is containing the entire data, out of which I would like to get only specific data related to column name. Okay. Then column data. Please remember these column names are case sensitive. So if you are saying giving a lowercase column name, you will get a key error because lowercase column name is not existing here. It's a uppercase column name, right? So you need to give uppercase. You will get the data. Are you getting the data? Column name related data. Column name related data you will be getting. This is a column name related data, and the same data you are getting at the bottom. Right? That is how you view only column name data. Right? The first row we have, right? Here, this first row. The first row data is getting displayed here. Like this. Column name related value 5, column 1 related value 10, 100 and 25 respectively. I would like to accessing a single cell by label. Value equal to df dot at 0 column name. Print single cell by label. What is the expected value? See, column name we have. Can you see this is a column name? And 0th index value, this particular value I'm trying to fetch. If you say 2, you'll get second index value of column name. But what I'm saying, I'm asking it to display column name related 0th index value. Can you see? So a single value also you can access using at function. Sorry, at attribute or a property. So accessing a single cell by position. I say value equal to df dot index at 0, 1. So 0th row first column. Single cell by position. Single cell by position print value. So what is that you are expecting? Can you see? How is that you are getting? 0, 1, right? So 0th row, first column. This is a 0th column, first column. 0th row, first row. So 0th row, first column is 10. That's how you are getting the value 10 here. Using instead of .iat, I'll be using accessing data using .loc. Selected data is equal to df.loc of 0 column name. Column name contains data, and at a 0th index data I am trying to access. This is selected data. So finally, conditional access. Selected data equal to df column name greater than 10, another column. What does it indicate? I want another column data, but condition has to be verified on column name. Which is saying, what is the output you are getting? Oh, int object is not subscriptable. So I need to close it here. Yes. Okay. Can you see? I'm taking, see here, column name greater than 10, another column data I want to get. Okay. So 35, are you getting 35? Yes. That's how you're getting another column data. Here, to get the understanding of data frame basics, you can have head, tail, right? Head and tail will give you first n number of records, last n number of records, which will help you in getting a quick snapshot of its structure and content. Likewise, you also have info method, which provides you summary detailing data types, normal values, and so on. Shape attribute, on other hand, gives you the dimensions of the data frame, like number of rows and columns. So we have some functions, we'll see them. Okay. The same data I'm taking. On the same data, I would like to perform all these operations. You need to take the same data. Data frame is created. Soon after creating the data frame, what is that we are looking for? We are looking for displaying first two records. So display first two records or rows, I say. Print df.head of 2. Can you see? I want to display last record. Display the last row. What do I do? Anybody? I shall wait here for your response. How do I do this? Why nobody is responding? Great. Tail of one is last one record, right? df dot tail of one. Next, I would like to provide a comprehensive summary of the database data frame. Print data frame summary. df.info. Can you see? You're getting the entire summary. Like this particular data frame contains 3 entries and the range index is starting from 0 to 2. And altogether you have 4 columns. And you can see the column names, the values, three values you have, and all are nominal values. Each is of int 64 data type. And memory usage is so and so bytes. That's how it is giving a complete comprehensive summary. When you call info over it. And also, I would like to get the shape. I would like to return a tuple representing the dimensions of the data frame. Like rows, columns. Rows, columns. How do I do? Simple. Data frame dimensions. Print df.shape will give you dimensions. How many rows? 3 rows you have, 4 columns you have, right? That's what? 4 columns and 3 rows. 3 records. Now it's time for us to look into the statistical operations. Statistical operations, Pandas. Pandas supports the computation of fundamental measures such as mean, median, along the exploration of correlations and distribution characteristics. So we shall look at some statistical operations like descriptive statistics. Descriptive statistics offer a snapshot of the dataset centralized tendencies and dispersions. What it is giving you? Descriptive statistics is giving you datasets, central tendencies, and dispersions. The describe function provides a quick summary, including mean, standard deviation, and quartile information. So I'm taking the data frame. I'm giving you, please make it available. Introduction to statistical operations in Pandas. When we are looking at descriptive statistics. So this is the data frame we have. Over the data frame, I would like to get the descriptive statistics. So print descriptive statistics for numeric columns. Print describe. When you call describe, it gives you the count, number of rows, mean value of each column, see, average. If you're taking 100 plus 10 plus 5, 115 divided by 3, what is that you'll be getting? No, sorry. Each column, right? 5 plus 15 plus 8. 20, 28. 28 divided by 3, you'll be getting 9%. So, likewise, that's a mean value. Standard deviation. Minimum value is 5 and maximum value is 15. And these are interquartile ranges. So, it gives you the descriptive statistics. So you can make use of the descriptive statistics in evaluating the student scores, getting the top marks, bottom performers, average, right? So later now, I would like to get mean value, standard deviation value, and median value. Calculate mean, median, and the standard deviation. Mean, median, and standard deviation. So for the same data frame I'm taking, actually it is defined at the above, I can make use of it, but for your convenience, later when you're exploring, you should not get confused. So I'm making it available in every cell based on the requirement. Mean value is equal to df dot mean, that's it. Median value is nothing but middle value, right? Median value is equal to df dot median. And the standard deviation equal to df dot STD. So later I would like to print it. Mean and likewise median value. And also I would like to print standard deviation. And you're getting mean value for every column, median value for every column. So now to separate, I'm giving one more new some formatted output. Yeah, you're getting separately mean value, median value, and the standard deviation value for every column. As describe is giving you all the data on single display. If you want a separately, if you want to display, you can go with the separate functions like mean, median, and standard deviation. Correlation analysis. What is correlation analysis? The correlation function generates a correlation matrix, indicating how variables relate to each other. Most importantly, you need to remember values closer to 1 or -1 implies stronger correlation, while values near to 0 suggest a weaker correlation. How these variables are related, we shall see. For the same, I'm taking correlation. How variables are related, it is going to display. The same data set I'm taking. And now I say I would like to compute correlation matrix. Correlation matrix equal. df.cor. Then when you try to display, matrix finishing, that's a correlation matrix. It is like if you want to correlate the number of study hours spent in learning versus grades, whether it is positively impacting or negatively impacting, these values will indicate. And also how the credit score is impacting loan repayment. If the loan repayment is good, credit score will be good, right? And you can relate number of hours exercise time to the calories burned. Exercise time versus calories burned. That's how it is establishing a relationship between the two variables. I would like to take the value counts. Here is the value counts. You can see value counts function tallies the occurrence of unique values in a categorical column, aiding the understanding of the distribution of categorical data. So you have a categorical data here. What are the three categories available? You can see out of your observation in this data. Out of your observation in this data, what are the three categories available? And I'm counting occurrences of unique values in the category column. Value counts is equal to df of category dot value counts. What happens? I was waiting for your responses. What are the three different categories available here? Very good. Mark them. I'm saying value counts. Before we look at the output, how many A values are there? 1, 2, 3, and 4 A values are there, right? How many B values are there? 1, 2, 3. And how many C values? 1, 2, 3. Let's check what is the output. Can you see? A you have 4, B 3, C 3. That is how it is giving you categorical values count. Again, at the end of the session, you have assisted practice. For your convenience, I'm pasting this assisted practice in the chat. We have taken house prices.csv, right? The related data set is a housing data set from which you need to perform this analysis, right? If you want, I'll post you the earlier step practice as well. Now let's look at date and time delta. Date and time delta in pandas. Coming to this lesson, we'll be catching up with date and time delta in pandas, date handling in pandas, like extracting the components from the date, and time delta in pandas, creating time delta, performing arithmetic operations, resampling the time series, and finally categorical data handling, creating a categorical variable, counting occurrence of each category, creating dummy variables, and label encoding. These are the steps we will be doing in pandas. So in pandas, the datetime module provides robust functionality for handling date and time data, while the time delta class allows for convenient manipulation of time intervals. And this combination is particularly useful for time-based analysis and working with the temporal data in data frame. Right? And date handling inputs. Creating a date range. The date range function is used to generate a sequence of dates within a specified range. So you can generate the sequence of dates within a specified range. It is also a powerful tool for creating times indices or date columns in the data frame. So to start and end parameters, the start and end parameters define the range, while frequency determines the frequency such as daily, weekly, and monthly. So there is a date range. You can see. We shall discuss the date range. I would like to take our session start date and end date. What are the start date and end date? Can anybody give me the start date and end date for your course? That would really help us to move further and perform a demo. Meanwhile, I'm importing pandas as PD. Then date range. What is the start date? PD dot date range. Let's say start is equal to 2026 03. Which date we started? And 12th, so very good. 12th March. And end date is 2026 for 3rd April, right? Some date, let's say. And the frequency is equal to daily. And I would like to print a date range. Can you see all the dates you're getting from 12 to 12, 13, 14 till 31st, later, first, second, third. That's how you generate the date range. D is the frequency, daily. D stands for daily. If you want to perform some kind of attendance tracking between the dates, or you would be checking the transactions, right? Bank related transactions for a specific period. Yes, this would help you. Now it's time for us to extract the components. Extracting components from dates. So I'm taking as PD, then assuming df is your data frame with a date column. So the date column here. So let's say data equal to date and say 2026 02 28. This is one date I'm mentioning. And another date 2026 to 3 15 I'm mentioning. Next I'm mentioning 2026 3 30. So the 3 dates we have taken. And if you can observe, there will be approximately 15 days between each date. df equal to pd dot data frame of data. And I would like to print the data frame. This is the data frame. Now what is that? I would like to extract month, day, month, and year information. How do I do that? df of day is equal to df dot df of date dot tt dot day. So df of date contains date, out of which from the date you are fetching only day. That's the meaning. Likewise, I would like to fetch month and year. I would like to fetch month dt dot month and also year df of year dt dot year. So all this, whatever you have taken data frame, to the data frame we are adding this column. Actually, your data frame is the one to which we are adding day here beside it, month and year. And I want to display the entire data frame. How do I display the entire data frame? I would like to display the entire data frame with the, I can say directly this way, print df. Are you getting the entire data frame? Oh, something went wrong. Let's check it out. df of day is equal to date dot dt dot day. Oh, so it's right only. Or day. Hmm. It's a data frame only, right? Date dot dt. Is that the data or data frame? Data frame date column only we are targeting, right? Okay, no problem. We shall try this way. 。 Next, we were accessing all this. Next is extracting weekday and weekend information. Weekday and weekend information, you can see here. We are starting at, let's say, I would like to change it to 2026. And third month, I would like to say today. What is it today? It's Wednesday, right? Fine. So I'm taking 17th. What I'm trying to do here, I have taken a data frame with the date and the date range with starting from 17th of March today. Periods equal to 5 means 5 dates it will create. And weekday, which will become a weekday, which will become weekend. When you divide a number, when you divide your date, weekday by 5, when you're getting a result as 1, I mean, starting from 5, 6, 7. 6 and 7, you'll be getting 1 by division with the 5. Then it will become a weekend. Can you see here? What is a weekend here? 21 is a weekend. Let's check it out. 21 is Saturday is a weekend, right? Can you see? Saturday is a weekend. How are you getting this one? It is printing you weekday. Weekday is 1. Weekday is 2. Weekday is 3, 4. And weekday is 5. When it is dividing with 5 is equal to 1, you are getting 5 divided by 5, 1. Then it is becoming a weekend. Right? You can take any date range. Let's say I'm taking 1st of March. 1st of March. And I'm running. Can you see? When you take 1st of March, 1st of March is, can you see? Sunday. Altogether, it is generating 5 days. And 1st March, weekday divided by 5. It is weekday 6, it is giving, right? 6 divided by 5, you are getting 1. It's true. So, your week is starting from 0. 5 and 6 are weekends. 5 and 6 are weekends. Hope you got it. Any doubts? So date range is creating a range of dates for the given periods starting from given starting date. So if you want to perform weekend and weekday sales performance, yes, you can do this kind of analysis. If you want to add a day name also, I have one more. So I need to go to calendar and check, right? Instead of that, df of day name, I can say df of date dot dt dot day name. And here also I would like to mention day name. That's how you get the day name also. Can you see? Sunday. I'm sharing you the modified file as well. It's time for us to discuss if shifting dates forward and backward, forward or backward. df of date is equal to pd dot to date time of df of date. I'm converting it to the date type. Later, df of previous date. I'm taking previous date is equal to df of date minus pd dot time delta of days equal to 1. So previous date I'm getting. And also next date I'm taking. Next date what you do? Simple. Next date you'll do df of next date is equal to same, but you'll do plus df of date plus pd dot time delta of days equal to 1. That's it. Then you can print data frame. You'll get to know. Oh, not going wrong. Pandas has no time delta attribute. Now time t uppercase. Always errors are good. Okay. So you can see here date, weekday, is weekend, and you can see day name. Along with that previous date, the 1st March is the current date. Previous date is 28th February. Next date is 2nd March. Likewise, here also you can see 5th March is the current date. We are trying to get date time. So we have a data frame. Let me get the data frame ready. So this is the data frame which is readily available to us. Right? Can you see what's happening? Let us understand. Here, data we have, which is in the form of a dictionary. We are considering hourly, frequency is hourly, and periods are 10. So 10 dates you will be getting based on hourly. See 0, 0, 1, 0, 2, 3, likewise till 9. And I'm adding 3 days. I'm adding 3 days to it. When I add 3 days, see 3 days has been added. Now what I would like to do, I would like to get the date, only date, right? We have in the data frame, we have date, we have value 1 and value 2, out of which I'm trying to get only date, which is converted to the date time and stored into the date. And that future date I'm saying, what is the future date? Plus the time delta, plus the time delta, weeks equal to 2, days equal to 3. See, for example, if the date is 1/1/2023, we are trying to add 2 weeks. 2 weeks is nothing but 14 days, right? 14 plus 15, 16, 17. Altogether, 17 days should be added to the current date, right? Let's check it out. Can you see? 1 plus 17 is 18. Right? Here, 2 weeks, 3 days, 12 hours is being added. Can you see 12 hours? So 17 days is added to 1. So it is becoming 18 days. It is 0, 0, 12 hours is added, 12 it has become. Right? That's how the arithmetic operations can be performed over the data. I want everyone to replicate this demo and let me know if you're comfortable. Data frame dot set index, I'm saying, of data. And in place equal to df resample is equal to df dot select data types of include equal to number dot resample of d dot sum. I would take to print resample. So time series data often comes with the irregular intervals, time interval, right? And resampling is the process of changing the frequency of the time series data, either by upsampling, increasing frequency, or downsampling. When you look at the values here, you have 0, 10, right? You have 0, 10. It is starting from 0 till 9 you are getting. It is starting from 10 till 19 you are getting, right? What is that you are getting? It is getting all the dates. You are getting all the dates, right? All the dates from here, you can see. All the dates, date is same, right? What it is sampling, it is adding up all the values, 0 to 9. It is adding up from 10 to 19. And finally, it has given you a value which is added up. We are summing up, right? All the value 1 and value 2 values are related to the date are added up. Hence, you are getting 45 and 145. Range is generating, Navinraj. Range is generating a sequence of values. I give range of 10, it is generating from 0 to 9. 10 is not inclusive. I am giving 10 range of 10 comma 20 and it is generating 10 to 19. 20 is not inclusive. That is step of 1. Hope I clarified your doubt. Resampling of D is nothing but daily. D stands for daily. And include of number, I am saying only numeric values it is including. Like value 1 and value 2. And sum, it is adding based out of day. If you want to get in the retail industry, if you want to get a aggregate hourly sales data to daily or weekly or monthly reports, or if you want to calculate the weather related average temperature from hourly sensor data, as you can get this done. Can you see? Here, what are the sequence you have given? In the same sequence, it will print the categories. Low is less than medium, less than high. It has categorized all your categories accordingly. So pd.categorical is taking the values and categories, and it is maintaining some order. What is the order? What are the order you have given? Low, medium, and high, and it is giving you the particular order. What I would like to do? I would like to count the occurrences of each category. So category counts is equal to data frame of category dot value count. Value counts is a function which will give you each categorical value count. Category counts. Can you see? You can observe here A is repeating 3 times, right? So hence you are getting A 3 times, B 2 times, and C is only once. We are counting the categorical values. In the real time, if you want to get a count of each product's category sold, yes, you can. Even if you want to get the number of tickets sold by priority, you might be having different category tickets and they might be getting sold. You can get them. We can also create dummy variables. So let's create creating dummy variables. So the same data frame I'm taking. Can you see? So category wise dummy variables it's creating. For example, category A, what you have? Altogether you have 6 values, right? So 6 values 0 to 5 it has created. And for category A, you have 3 values. Category B, you have 2 values. And category C, you have only 1 value. Likewise, it is creating your dummy variables. Are you running the demos? When you want to work with the machine learning models or statistical analysis, creating dummy variables is often necessary to represent the categorical data numerically. So in general, if you want to mention the categorical data, generally machine learning models will take every data in a numerical style. And if you want to convert the categorical data into the numerical data, yes, get dummies will be helpful to you in creating such numerical values. And get dummies function is creating a binary columns of for each category here, effectively converting categorical data into a numerical format. You can see here, right? Yes. Can you see? Category, and for category A, it has given 0. Category B, it has given 1. And category C, it has given 2, right? Likewise, label encoding is happening for every category. It is converting every category to the numerical columns through label encoding. So this is very much useful in scenarios where ordinal relationships exist between the categories. Like product type, you have shoes, shirts, trousers, right? And every category will be given some value, unique value, label encoding through. So let me take whether if it is available, I shall take the existing code to save some time. Can you see? I'm taking this code only to save time. You can see here. Please try to understand. I have a column. I'm creating a data frame here from the column, and a column containing these values. Hello, old, Python, data science. Now, what is that I'm trying to do? I'm trying to add a length column to the data frame. Actually, this is the data frame which is having only column. But at a later stage, I'm trying to add a length column and trying to get a length of every string and add it to the data frame. And I'm trying to print the length of each string. Can you see? I'm getting hello, length, old, Python, and data science. So this is how you call over a data frame column dot string dot length. It will get me length of every string and add to the length column of the data frame. Right? So in social media analysis, you may count the character length to see if posts are concise or lengthy. As you can get this done. Or customer feedback analysis, you can it can determine if the short or long reviews tend to more positive or negative analysis. I would like to convert the same data frame, f of lowercase I said. And I want to convert these strings to the lowercase. F of column dot string dot lower. Oh, sorry. Something went wrong. Contains substring. Sorry. You see? So here data is a substring and I'm checking whether every column data I'm checking by passing the substring. And it found to be there is no substring data in this string. Hello, old, but here is a data substring available in data science. Hence you are getting it true. Okay. So in email filtering, you might be finding the emails which is containing the bank related or training related subject lines, right? So in such cases, it will be helpful to you. Yeah, sure. Perfect. See, I have a data as a substring. I'm passing this substring and checking every column whether the string contains the substring or not. If the data substring is containing, then it is printing you true. You can say this data is available in data science, but none of the other strings is having the data. Hence, you are getting false. Right? Very simple. Martha, hope you got it. Okay, good. Fine. We have a column data, column 1 and column 2, right? Column 1 is having 1, 2, 3. Column 2 is having ABC. What I'm trying to do, I'm trying to call iter rows, which is helping me in iterating all the data. Row wise iteration will happen. And row wise, I'm trying to get index. These are the indexes. These are the rows. Index will be stored into the index. Row will be stored into the row. And I'm trying to print index and the data row. Column 1, data row, column 2. Right? Let's see, check it out. How is that really? Can you see? Okay. Default indexes it is considered. Default index is 0, 1, 2, right? When you try to print the data frame, see, let's say data frame I'm printing. Can you see? This is the default indexes we are getting, column 1 and column 2. So the same indexes we are trying to print in this way. Index as so and so. And data related to column 1 and column 2 getting printed, right? With the help of index, data related to row of column 1 and row of column 2. Index is say default indexing bar71 default indexing is 0, right? You can see 0 index, first index and second index. So the default index is given for the data frame. Every data frame will be getting the default indexing. And that indexing we are printing. Right, thank you. I would like to apply a function. Apply a function. Each element. df equal to pd dot data frame of I'm creating a column, existing column. And, with the values 10, 20, 30. Right? df of new column, you see. df of existing column dot apply. I'm applying a lambda function x colon x into 2. 2 times I'm multiplying every value. So what could be the new column values? I'm printing the data frame. Data frame now contains the existing column with these values. And the new column values over the existing column, I'm applying a function, lambda function, x colon x into 2. So 10 into 2, 20 into 2, 30 into 2. That could be the values for the new column. Can you see? If you want to transform a column values, like if you want to apply some discount over the selected items, yes, you can do that. A e-commerce company can calculate the total cost of 2 units of each product, or can go for electricity billing, estimated bills if usage is doubled, likewise. I would like to say a result column. In the result column, I would like to add, like you might be having 2 subject marks. So 2 subject marks, I would like to add and display the total marks, something like that, okay? df of column A plus df of column B. Print df. Can you see? Column A has 1, column B has 4, and the result is 4 plus 1, 5. Likewise, 2 plus 5, 7. Getting some vectorized operations, column related values we are adding. You can also find difference, product, division, right? Everything you can find. I want to perform iteration over the rows, over the series. Okay, iteration over series. Let's say I have a series is equal to pd dot series, right? 10, 20, 30. I would like to give the name to it as name equal to values. Name equal to values. Now for index comma value in series dot items. Print. Like to print using formatted statement. Like to print index. Value. You can see here. Index is 0, value is 10. Index is 1, value is 20, likewise. So I can perform iterating over the rows and print the values accordingly. So it helps you in getting the test scores of different subjects and print for you. I can also do this way. One more example on the same line. Subject marks I'm taking 70, 88, 67. And I would like to give index is equal to math, science, English. And the name equal to scores I'm giving. Fine. For subject, comma, score in series dot items. Subject is math and score is 70, likewise subject wise. Indexing we are giving here. Instead of going for default indexing 0, 1, 2, I have gone for a customized index. See, like we can avoid giving name also. But if you want to, see, we are iterating, right? We are iterating over the items. Name will help us in identifying that series. So we are giving some labeling like column in the Excel. When you're trying to print the series, you see. Can you see? Name is course. It is like a column for the marks. Did I clarify your doubt? Navin Raj? Partha? We haven't gone for sorting, Walsam. Yes, now Balsam has asked related to sorting. We'll see sorting. For example, I have a data frame. Let me take the data frame from the existing code. I'd like to take this data frame. Right. And what I like to do, df underscore sorted is equal to df dot sort values of y equal to age. And I would like to print sorted data frame by age. Fashion df underscore sorted. See, generally, I would like to print the actual data frame, then sorted data frame. Can you see? This is the actual data frame where you have this order. But after sorting, you can see the order by age, it is sorted, right? If you want to, you can see this is an ascending order, right? Also, this is ascending order. Now we shall look into the descending order. Same thing. I'm trying to display in the descending order. df dot sort values of by equal to what I give? Age. Sorry. By age and the comma ascending equal to false. Now you can see in the descending order. Hope I clarified your doubt, Walsam. Right. Now I would like to perform sorting with multiple values. Sorting multiple values. Multiple columns. df underscore sorted multi is equal to df dot sort values by age and salary. I would like to perform sorting, comma ascending equal to print sorted data frame by age and salary. Can you see? Ascending is true for age, so it is following the ascending order, and the salary false, so it is not following any. For example, you try to make two salaries same, and observe the difference. You will get to know. So I'd like to perform sorting data frame by index. df underscore sorted index is equal to df dot sort index ascending equal to false. So I would like to print sorted data frame by index. df sorted index. Fine. So let's see. Say here indexes are 102, right? Now we are sorting by index. You can see. Can you see sorting by index? Ascending equal to false. You can see that descending order is index. By default, it is ascending order. But I have given here ascending equal to false. So you are getting a descending order. Now let's perform a sorting of series. Of series. Or sorting a series. I would like to take a series equal to pd dot series of 25, 22, 30. Index equal to say Alice, Bob, Charlie. These are the indexes. Name equal to age. Right? I given the name to the series as a age. Series sorted, I would like to get is equal to series dot sort values ascending equal to false. Now I would like to print sorted series by age. Series sorted. Can you see? Descending out of the ages, we can get the series. Now, very interesting thing, folks. Hope you all are comfortable plotting with the pandas. I would like to import pandas. Speedy. I would like to import Matplotlib. Matplotlib is a plotting library which contains pyplot. I am importing it as PLT. Yes, we are naming the entire series by the name age. Can you see the name image? So I'm taking a data. I'm also taking a another column data. The data frame I'm creating from this data, pd dot data frame of the data. Data frame has been created so that div.plot, when I call, the plotting will happen. Plot.show, when I say, it will show me the plot. Hey, here is colon, sorry. Right. Can you see? A values from 1 to 5. B values from 5 to 1. This way, the plotting is done for this data points. So that easy, we're creating a plot. Index is 0 to 4 in the x-axis. Can you see? 0 to 4 in the x-axis. And values are 1 to 5 and 5 to 1 in the y-axis. Increasing line and decreasing line, you can see. Like you can relate it to the sales dashboard where you can compare the revenue versus expenses, or health tracking where you can compare with the weight versus calorie intake, or even you can consider it to the stock market trends where prices of different stock over time to compare performance. The same plot, same code. Oh, I have given you the code is exactly, you're right, Basu. Here is it is a dictionary, A category and B category, and list of values. We convert it to the data field. Here, I would like to say plot and the kind equal to bar. Let's see. Are you getting bar? Simple. One thing I have added, you can see at the 0th index, value is 1 and 5. At first index, value is 2 and 4. 3 and 3, like this. Makes sense, right? I have shared you the code, earlier code. Just give me a minute. I'll share you these values as well. Yeah. I share you the code. I'm giving the right now new code. And at the end of the lesson, you have assisted practice again. I request you to get this done. And I'm giving you in the chat for more convenience where you can take it from you. I would like to rename our file day 4 to pandas and data visualization. Right? Now it's time for us to discuss data visualization. Always remember, data you have in hand But if you want to visualize the data, it is really important to plot a graph. You can plot a existing data in the form of a graph with the help of Matplotlib. In the data visualization, you have different plots like line plot, we have, likewise scatter plot, and also bar plot. Box plot. Ladder chart, area plot, polar plot, tree map, pie chart. These are the different plots we have. We shall look into one after the other. Excuse me, are you comfortable till here? Meanwhile, we shall perform a knowledge check before going to the lesson. Hope you are ready for the knowledge check. Here is the knowledge check. Hey folks, all of you get ready. How can we access the column age in the pandas data frame named df? Please send me the option. Send me the option. Either A, B, C, or D. Hey, is it? Sorry. Can you see now? Please give the right option. Great. All of you, you're right. The option is C. Right. Next, which if pandas function is used to obtain a summary of descriptive statistics named data from df? That's great. I can see a good number of responses. Fine. Answer is A. You're right. Next, how is the year extracted from the pandas series data series containing date time objects? Okay, hope you get it. I'm looking forward for your options. Yes. Option is C. Right. Option is C. Right. And let's get into the data visualization now. Data visualization. Let's look into the introduction to data visualization. Data visualization is a graphical representation of data to reveal patterns, trends, and insights that might not be easily apparent from raw data. See, raw data, if you look at the raw data, it will not give you that much insights, right? See, when a cricketer is coming onto the field, if a raw data is getting displayed, it cannot be understood by everyone. But the same data for the last few matches, how is its performance? If it is displayed in the form of a graph, that makes more sense. Always, picture speaks louder than raw data. That you need to understand. So it involves creating visual elements such as charts, graphs, and maps to communicate complex information in an understandable and interpretable form. Data visualization tools and libraries such as Matplotlib, Seaborn, and Plotly empower analysts, scientists, and business professionals to create compelling visualizations that enhance the understanding of data and support evidence-based decision making. And here we have an introduction to Matplotlib. So what is a Matplotlib? Matplotlib is a comprehensive and widely used data visualization library in Python. It provides a flexible platform for creating static, animated, and interactive visualizations in Python. So with the help of Matplotlib, we can create a variety of graphs like histogram, pie chart, subplot, scatterplot, bar plot, and tree map. And we are into creating a line plot now. Okay. A line plot is a basic chart that displays information as a series of data points connected by straight line sequence. Hence, we call it a line plot. It is particularly useful for showing trends over a continuous interval of time. Here, most importantly, you need to remember, we are getting our hands onto the line plot. So, import Matplotlib pie plot as PLT, import NumPy as NP, execute NP dot in space, I say 0, 10, right? What does it mean? It will create 100 data points between 0 and 10. Okay, I'm giving 100 and it will create equally spaced values between 0 and 10, 100 values. Let's try to print what x values. Can you see? These are the 100 values. Right? So I don't want these x values, just for understanding I have taken. Likewise, y equal to numpy dot sign of x. For every x value, sign value is getting found and stored into y. Later, I try to create a plot. PLT dot plot of x versus y. And I would like to give the label equal to sine wave. What is that? Sine wave. And also, I would like to give color. Color of the line is blue. I would like to give. And the line style. Line style equal to dash. The line width also I can give equal to 2. Thickness of the line. Later, I'm adding the labels. Added labels. You please try to follow the same way will be for every graph. What I have taken? First, I have taken the data. So this could be the generating data for a line plot. And this would be the line for creating line plot. And here is a code for adding the labels and title. Plot dot x label, x axis, and the plot dot y label of y axis. Then plot dot title. I would like to give the title for the plot. Line plot, sine wave. Then I would like to add a legend. Legend is plot dot legend. And finally show the plot. Plot dot show. Once again, I'm repeating. Please concentrate. Here we are importing the required libraries, then generating the data for x-axis and y-axis, the 100 data points between 0 to 10, and the same values I am passing it to the sine function so that it will create the y values. And I'm plotting the line plot between x and y, and I'm giving the labeling. Why labeling is important here? When I call legend, in the legend, this label will be shown. Okay, color equal to blue. Line color is blue. Line is a dashed line, and line width is 2. And x-axis I'm labeling as x-axis. Y label I'm labeling as y-axis. Plot title I'm giving line plot sine wave. When I call legend, this label will be shown in the legend with the blue color. And when I call show, plot will be shown. Can you see there? See, this is the legend I'm talking about. You can see y-axis, x-axis, and it's a title. That's how the sine wave graph looks like. SS, see, x values versus y values only, it is generating the graph. See, I give plot of x comma y, right? For every x value, the respective y value will be mapped and you will be getting the graph. Every point is a x comma y. How many of you have got the graph? Please respond here. Great, Partha. Anybody else? Interval is defined between the values only. See, I'm trying to print the x value and y value, right? Print x of, I would like to get for first 5 values. I would like to get first 5 values. And also, I would like to get the y of first 5 values. Can you see? These are the x values. First x values. These are the first y values. 5 y values. And the plotting is happening accordingly. Okay, Balsam? Yeah. So in the real life, you can go for visualizing the temperature changes over a day and week, or tracking stock prices or trends over time. And in education, you can see number of hours spent versus marks scored. Plotting can be done anyway, right? It's time for us to look into the scatter plot. I'm taking the same libraries. Actually, if you import once, that would be enough. In the Jupyter notebook, entire Jupyter notebook, they will be available. But still, for more convenience, I'm importing again. And here I'm generating data for a bar chart. I'm taking categories equal to category A, category B and C. And values equal to and I would like to create a bar plot, bar chart, etc. Plot dot bar is a function. I'm taking categories and values, categories versus values. I'm trying to create a plot. And I would like to give the color as orange, then edge color equal to black, right? And the label as a bar chart. Fine. Next, I would like to add the labels and title. Plot dot X label. I would like to give X label as categories. And Y label. Y label as values. Then title as a bar chart, indicating category comparison. And plot of legend, and plot of show. Fine. You can see categories. Category A value is 25, right? Can you see? A value is 25. B value is 40 and C value is 50. And y-axis values to the maximum value, it is adjusted 40. Maximum value is 40, right? So it is adjusted to 40 automatically. And the categories you can see this way. This is the legend. It's a title and y label and X label as categories. Fine. That's how we visualize the data. So visuals speak louder than the raw data. Fine. We call the box plot as a box and whisker plot, which provides a graphical summary of a distribution of dataset. Box plot also displays the minimum, maximum values, median value, first quartile and third quartile. Okay. And also if the data is spread beyond these values, outliers also it will display. Let's say I'm importing the required libraries. Importing the required libraries. Then I would like to take the data, generate data for box plot. Data equal to np dot random dot normal of 0, 100, 0 to 100 values it will generate. np dot random dot normal 0 to 1.5 it will generate 100 values, and np dot random of dot normal 0 to 2 I would like to generate 100 values. So that's what the data is getting generated. Altogether 0 to 100 values, 0 to 1.5 values, and 0 to 200 values it is generating. For this data, I would like to create a box plot. For creating a box plot, plot dot box plot of data labels is equal to, I say, group 1, first set of values, sorry. First set of values I'm saying as group 1. And next set of values I would like to say group 2. Let's run and visualize the data. Meanwhile, if you can see here, I have given plot, right? And you can see patch artist equal to true. It will fill the box with the color. It will fill the box with the color, patch artist equal to true. And a notch equal to true adds a notch around the mean to help compare a median between the groups. It is adding the notch, can you see? This notch. This is a notch it is adding. So median value we are able to compare. And observe carefully, this would be the minimum value. This would be the maximum value. Here, it is a minimum, the maximum, and here notch is there, right? That is a median. And this is called as third quartile. Third quartile. Q3. Median is nothing but Q2, right? And this one is a first quartile. Q1. And you can see this is a circle, right? These are the outliers. These are the outliers. Outliers are the data which are moving away from the actual data. Fine. That is how the box plot is displaying you the data onto the visuals. So boxplot will give you the quick overview of the distribution. It will help you to spot outliers easily, and it is very great to compare between the groups. See, this is a group 1 data, group 2 data, group 3 data, and you can see how the data is getting distributed. Okay, now it's time to discuss the. Are you comfortable? Shall we go ahead and discuss the radar chart? Or we call it as spider chart. Matplotlib dot pyplot scale import NumPy as an input. Then I'm creating generate data, random data for a radar chart. I'm taking categories is equal to. I'd like to take category A. Likewise, category B, C, D, E. So altogether 5 categories I have taken. So also I'm taking data equal to input dot random dot ran int. It will generate the integer values 1 to 10 for the length of categories. So 5 values it will generate. Okay. And now I'm writing the code for creating a radar chart. Create a radar chart. I'm taking angles equal to np dot line space of 0, 2 into np dot pi 2 pi, right? 360 degrees. Length of categories endpoint false. And data equal to np dot concatenate data data of 0. Angles equal to np dot concatenate of angles of dot polar angles data marker equal to later. I would like to add labels. Plot dot theta grids is the function related to the radar chart, where it will help you in add the labels. Np dot degrees angles. The labels equal to categories. Plot dot title radar chart random data. Okay, 1 minute. Somewhere it went wrong. Theta grids np dot Angles. And plot.show. Yeah, here concatenate of data we have, right? So concatenate will take 2 brackets. Yeah, can you see? Random values. I'm running again. You can see, right? For a better view. You can see 2, 4, 6, 8. Right? And here category A is having some 8 value. Category B is having something 5. Category C again 8 value. Category D 2 value. Category E is having 10 value. Right? Let us look into the explanation. When it comes to the explanation, here radar chart is also called as a spider chart, which is used to compare the multiple categories. Here we have taken categories as category A to category E, and we are generating the data 1 to 10. Like if you can compare it to the skills related to a person, okay? Category A would be a communication skill, category B would be a soft skill, category C will be coding skill, category D will be presentation skill, and likewise category E would be the subject knowledge. And accordingly, we are having the data scores from 1 to 9. 1 to 10 it's generating 1 to 9, right? For each category. Later, we are taking the length space 0 to 2 into npi, right? 2 pi. Full circle it will make 0 to 360 degrees. For the given length of categories, 5 categories we have. And here I have given the endpoint equal to false. Right? Endpoint, it is not creating any kind of endpoint here. 2 pi is 2 into np dot pi, 2 pi radians. 1 pi is 180 degrees, right? 2 into 180, 360 degrees you get. And concatenate to the data, I am giving data and data of 0. And also angles, I am giving angles and angles of 0. So what it does, it is closing the loop. Concatenate is taking the data and considering the first value at the end. Likewise, angle also, you can see here angle, right? Marker equal to O I have given. So the data point is marked as the little circle. And theta grids, I'm giving. The theta grids is taking the angles, convert the angle from radians to degrees, it is converting. Right? And it is mentioning the labels. Then I am giving the title and asking it to show the plot. As I told you, category A would be the communication, category 2B will be the technical skills, category C would be the leadership, category D would be coding skills, and category E would be the creativity. And all these skills has been compared, and a graph is being shown to you, which will be helpful to the visualizing the full radar chart. Hope it is clear. Let me run. You can see the plot here where the area plot is generated. Can you see? Area between the curves. Here, X is the values which is generating between 0 to 500. So can you see 0 to 500 values it is generating, right? And y-axis, y1 I have said, y1 equal to x I am assigning, y2 equal to x to the power of 2. What does it mean? X square. So we squared all the values. Then we are generating the by giving all the three values x, y1 and y2. This is the area plot it has generated. So here, this is the area between the two curves y1 and y2. y1 is x values, y2 is x square values. So these are the x square values and these are the x values. And in between you have the area. Right? So that is the area plot. Okay. Alpha equal to 0.5, I have given 0.85 give. You can see the thickness, darkness in the graph. Can you see? It represents the transparency of the graph. That's all about the area graph. So you can consider here y1 is a expected monthly expenses. Y2 is a projected monthly revenue. So, and the area between these lines would show profit over the time. Or you can consider y1 as a daily average temperature in city A. Y2 is a daily average temperature in city B. That shaded area, whatever you are getting, shows how different the weather is between two locations over a period of time. Right? Hope you are able to relate. If you're done, please let me know. We shall look into the polar plot now. Polar plot. Polar plot represents data in polar coordinates. Polar coordinates. And it is useful for visualizing cyclic patterns and relationships. Yeah, use of x, nothing but we are creating a x value, right? Here, x is representing these values only. X, y1. Y1 is, see, these are the x values. These are the x values, right? This area. And y1 is drawing a line. This line. Y2 is drawing another line. And the filled area is nothing but area between y1 and y2. These are the x values. Getting? Naveen Raj. shall go for the polar plot. So let's import the required libraries and generate the data. Theta is equal to np dot in space 0, 2, 2 into np dot pi 100 values in generated are equal to theta into 2. We have taken two values here. Theta as in some 0 to 360, 100 values in generating. And all those 100 values we are squaring and storing. We are multiplying by 2 and storing to all. So I would like to create a polar plot. Plot dot polar is a function which takes theta with r values and labeling as a polar plot. Plot dot legend. Plot dot show. That's it, simple. You get a polar plot. Can you see? So it is taking 100 values and it is generating a polar plot. So polar plot is used in a radar systems where aviation or submarines will detect objects by angle and distance. Or audio signal analysis also you can use. You shall plot, visualize phase shifts or a sound wave direction. Physics and electromagnetism you can use to visualize magnetic fields or wave propagation in antenna design. Excuse me, is that okay? Shall we go for the tree map now? A tree map is used for effective way of visualizing the hierarchical data structure. So we shall take the hierarchical data here. I wanted to take the hierarchical data. So sample hierarchical data. Data is equal to row branch 1, leaf 1. Anything? Leaf 2. 30. So this is branch 1. Likewise, branch 2 I'm taking. Branch 2, leaf 3, 25, leaf 4, saying 15. It's the hierarchical data we have in hand. So I would like to define a function now. So I would like to define a function now for flattening the hierarchy. Function to flatten hierarchical def flatten hierarchy is taking node and parent equal to nothing. And I'm taking items plus nothing, empty list. Later for key comma value in node of items. What is it doing? From node is a data which you are passing, this data we are passing to flatten hierarchy, and from node it is getting the items. Okay, and key comma value it is separating if is instance of value from a dictionary. So what it will do? It will do items dot extend of, again I'm calling the flatten hierarchy. See, it is separating key and value. So when it is separating key and value, this is a key and it is a value. Again, value is again a dictionary, right? So we are checking it is an instance of a dictionary or not. If it is a dictionary, again I am calling the same function so that it can further flatten the data. That's how it is functioning. Comma value parent equal to parent and key. If parent else right? Else let's say items dot append of parent comma key comma value. And finally, it is return items. So flatten the hierarchical data for remap plot. Flat data is equal to flatten hierarchy. I want to plot a tree map now. So for plotting tree map, see, you can see here, actually this function, whatever we are defined, we are calling here by passing the data. What happens? It will take the data as a node and it will try to get the key and value. And what are the value it is fetching? See, in the first step, it will get this value. And this is a dictionary. So each instance becomes true. Again, it recalls the flatten hierarchy by taking the value, this value, and further it will optimize. And again, it will get the value here. This is the value. The value is again checking. Value is again an instance of a dictionary. So again, it will keep on calling the same function so that it will get only values separately. Okay, that's how it's happening. Finally, it will append all the parent key and values to the items. Fine. If you want to check, you can check what is the flat data. Print the flat data. You see, flat data looks like this. Root to branch 1, leaf 1, root branch 1, leaf 2, like this. List of tuples, you see. Yeah, sure. Once again, I will explain. See, this is the data. You can observe carefully now. This is the actual data, right? when you give this data to the function, it is getting the items. Items is nothing but key value pairs. So in this context, this is a key. And remaining entire thing is a value. Branch one, everything is a value. So value it is we are taking, and it is checking is instance of value is a dictionary or not. Of course, value is a dictionary, right? You have again key value pairs, key values, right? So what it is doing, it is calling the function again by passing value and indicating parent as a parent slash a key. Okay. So here parent is nothing. If parent, else key. So what are the keys taken here? Root as considered as a parent. Later, again it is calling. Now, when it is calling for the next time, this would be the key, and this is the value, right? So it is passing again to the instance value. This value is taken and checking whether it is dictionary. Yes, it is a dictionary. Again, it will call the function. Otherwise, it will append parent key value. Fine. So likewise, it is appending branch one. You can see the items data. Root branch one, leaf 1 20, root branch 1, leaf 2 30, like this. Is that okay? Have you got it, Navin Raj? So at the moment, we are going for creating a plot. Fig comma ax equal to plot dot subplots of a fixed size I am giving is equal to 6 comma 6. And then squarify dot plot sizes is equal to item of 2 per item in flat of that. Then label equal to formatted string item of 0 slashing item of 1. Item of 1 per item in flat data. And alpha equal to 0.7, you know, it indicates the transparency. X equal to x. Plot dot axis of I'm saying. I'm removing the axis. So remove axis labels and fix for better appearance. Yes, fix. Okay. Then I'd like to go for the title of the plot. Product title, remap, sample hierarchy. Then plot dot show. Okay. There's an name error. Squarify. verify the plot sizes. Just a second. Verify is not different than sales. Okay. So we may need to import this verify. For that I'm importing. Okay. Module not found. No. Import verify module is not found. No problem. Just give me a minute. Click install verify. I'm running. Downloading. All of you run this. Click install verify. This would be the last demo for today. Sorry. Hey, still you are getting not verify not found. I need to restart the kernel. Okay, we shall restart the kernel. Restart kernel. Okay. Restarting is completed. Let's run again. Now we can see the tree plot. Can you see? root branch 1, branch 2, root branch 1 and branch 2. Leaf 1, leaf 2, leaf 3, leaf 4. That's how the tree map will be created. So it would be helpful for you to represent the relationships. Like sales analysis, category wise, subcategory wise, sales distribution if you want to see, as you can see. Market share, industry wise, sector wise, market share if you want to see, you can see.
Guys, with that, we have come to the end of this course. If you have any doubts or questions, you can ask them in the comment section below. Our team of experts will reply to you as soon as possible. Thank you and keep learning with Simplilearn.